Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to install SIMATIC Step7 step by step on Windows 7 64-bit with page 1. Okay, so first we will install the SIMATIC PC Adapter USB version 2.0. After that, we will install PC Adapter USB A2. It is very important because we cannot install the SIMATIC Step7 directly. Otherwise, we cannot communication between our PC with the PLC. Okay, so we need to install the SIMATIC PC Adapter USB and SIMATIC PC Adapter USB A2 on Windows first. Then we will install SIMATIC Step7 version 5.6, and then we will install SIMATIC WinCC Flexible 2008 with page 5, and then we will install the SIMATIC PLC Sim version 5.4 include with page 8, and then we can create a new project for test with our software. Okay, so first install the PC Adapter USB 2.0. Okay, so let's go step by step with me together. Okay, so here is the software that we will install, but we will follow the step, otherwise it will be not work correctly. Okay, so first install the PC Adapter USB. So right click, run as administrator. Okay, here is the Windows 7. Yes, with page 1 version and RAM only 4 GB because right now I run on VMware player. Yes, so run as administrator, and then choose the language that we want. For me, I will choose the English language. Click next again, and then click next again, and click accept the through license agreement. Yes, you can read the license agreement here. Yes, and then click next. Here is the two choice that we want to install. The first one is Adapter Acrobat version 8, and the second one is PC Adapter USB. Okay, so right now I don't want to install the Adapter Acrobat, so I will uncheck the box. I install only PC Adapter USB version 2.0. Okay, and then click next and wait for installation complete correctly. Yes, it use time around 3 to 5 minutes for this installation. Okay, so wait a moment for this installation. Actually, if our computer is RAM around 8 GB or 16 GB, it will faster than this. But right now I choose only 4 GB for Visual Machine. Yes, VMware player. So it will slow a little bit, but no problem. It can install. Yes. Okay, right now it finished installation. So click finish. Yes. And finish again. And I will reboot the PC before I go to install the PC adapter USB A2. Okay, so I will restart. So right now the computer is restarting. So we need to complete the step, otherwise it will be not work correctly to connect with the PLC. Okay, so please follow me step by step. Okay, so right now the computer is restart successfully. So we will continue to install the PC adapter USB A2. Yes. Okay, right click run as administrator on the setup folder. And then click next. And wait a moment for this installation. It will use around 3 to 5 minutes more for the installation. So wait a moment. Okay, installing. Actually, it also support for Windows 10, 64-bit and 32-bit also. Yeah. So we can install the same as procedure that I already show on the slide. We need to complete the step, follow the step, otherwise it will not work correctly. So right now it installed the PC adapter A2. Yes, nearly finished. So wait a moment for this installation. It is the driver for connect with the PLC. Yes, otherwise we cannot communication between our PC to the PLC if we don't install the driver for communication. Okay, so driver communication is very important. So we need to install it first, otherwise we need to reinstall again after we install the software SIMATIC Step7 version 5.6. Okay, so wait for installation. Otherwise we can we cannot use it if we don't follow my step, because I already test some software. If we not follow the step, we cannot use properly after installation. Okay, actually this software we can use for communication with PLC S7-300, 400. Yes, so we can use for create the new program, backup, upload and download program. Yes, from the devices of PLC S7-300 and 400. Okay, so right now it finished the installation and we need to reboot our PC again. So click finish to reboot our PC. Okay. So wait a moment more for reboot the PC. Okay. So right now we already reboot the PC. So the next step we will install the Step7 Professional version 5.6. So let right click run as administrator. And then choose the language that we would like to install. For me, I will choose English language. Click accept button, the license agreement. So we can read the license agreement. And then click next. And here is the component that we will install. So please choose all. and then click next. And then click accept the license agreement again, and then choose next. And click install to install. And it will use time around 30 to 40 minutes for this installation. Step 7 version 5.6. Okay, so waiting for this installation complete and successfully. It will go step by step by follow this step. Yes. .NET 4. Yes. Visual C++ 2010 EP1. Visual C++ 2012. Yes. And component, and then it will automatically install step 7 version 5.6. Okay. So right now it's installing the component. Yes. So it will finish the component and then continue to the step 7 version 5.6. Yes. Okay, it nearly finished for installing the component. Yes. So right now we will install the step 7. Yes. Version 5.6. So click next and then click next. And here is the username that we would like to put. Example, I put PLC also, or we can put your name that we want. Example, I put PLC S7-300. Click next and then choose the typical or minimal or custom that we want. I recommend to choose typical. Yeah, and then click next. And we must choose the all language, because if we don't choose the other language, it will cannot open file. Example file with the French, Spanish or Italian, so we cannot open. So please install all. And here is the license key. So no need to install the license key. I will install later. So click next. And then click install to start install step 7 version 5.6. Okay, so it process installation. It will take time around 20 minutes more for this installation. So wait for this installation finish correctly. Yes. Okay, so we can click the skip first for license installation, and then we will click finish to restart our PC. So the PC is restarting right now, and we will continue to install the WinCC Flexible. Yes. Okay. So let's see, here is the program that we already installed. Yes. So the next step, we will go to WinCC Flexible, and then choose the Run as Administrator on the Setup application. Okay, it 2008 includes the EP5. Yes. So it is the latest version. So click choose the language that we want. For me, I choose English language. Click next, and then click next to install the program. Click accept the license agreement, and then choose next. And then I will install all the languages that we will use. Otherwise, we cannot open the project with the another language. Yes. So we need to check box all for this installation. So click install, and then choose the type call installation. Yeah, and then choose this one also, and then click next. Click accept the license agreement again, and then choose the next one, and it will start installation. Okay, and this one, it will use 40 to 50 minutes more for this installation. Yes. So wait for installation completely. It includes the process also, version 14, with page 1. We can also back up the HMI project from the HMI Siemens by using this software. So if we install the WinCC Flexible 2008 with page 4, it will include the SIMATIC process version 14 with page 1 also. Okay, so it's very important. So wait for this installation complete successfully. So it will restart, yes, the computer before go to installation continue. Yes, so click OK to restart. Okay, so right now it already restarted the computer. Yes. So we will go to software again, but it will installation continuously. Yes, after it restart. Okay, so right now it install finish. So click finish to restart our PCs. So here is the WinCC Flexible that we just installed. Yes. So next we will install the PLC Sim. So run as administrator for setup application. Choose the language that we would like to install. For me, I choose English language. Click next. Click accept the license agreement, and then click next, and click OK. And for automation license manager, we already installed. So we need only S7 PLC Sim version 4 includes with page. Version 4 5.4 includes with page 8. So click next. It will continue installing. After the installation, I will create the new project and make the simulation for show to everyone also. Yes. So let follow me for test our software after installation. Okay, click next to continue installation. Then click next again, and click install. Okay, click skip and then click finish, and I will restart the PC. Yes, before we create the new project for simulation. So I will create the new project for simulation and testing. Yes, so let's go. So we can simulation. Let me test. So if I would like to start the motor number 1, I just press start. Yes. Let's see, the motor number 1 is running. Yes. Change color to green. And if I would like to start motor number 2, I'll can start also. Yes, start. Let's see, the output is turned on. If I would like to stop, I just press stop. Press stop. Start again. Start again. Yes. So this is just instruction about how to install the software step by step and create a new project for simulation in this software step 7. Okay, so please follow me step by step, otherwise we cannot use this software. Yes, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again. Today we will learn about SIMATIC Manager software, how to create the configuration I/O or CPU for simulation. Okay, so first let's open the software. Okay, and then create a new project. Example project, example tutorial 1, hardware config. Okay, hardware config, and then we will create the new folder for this project. Example SIMATIC Manager hardware config. Okay, so we can browse to find this folder that we already created. Okay, then click OK and OK again. Okay, we will get the new project. So first we need to create the rack for the PLC. To create the rack, right click here and then insert the object. Okay, in this simulation program I use SIMATIC 300 station. Okay, so let's click SIMATIC 300 station. Okay, so it will insert automatically when we click SIMATIC 300 station. Then double click here and then go to hardware. Yes, this is a blank, not yet create some rack or some I/O. Okay, so let's create the rack first. In the right hand side we see a lot of station like S7 SIMATIC 400, 300, Profinet IO, Profibus DP. Okay, many components that we can use. Okay, so first I will create the rack for SIMATIC S7-300 first for simulation. Okay, so let click the rack 300, and then we will see the real. Okay, so to create from this to this, we just drag and drop from this and then drop here. Okay, we will get the one station that it have 11 slot for PLC IO. Okay, so first we will continue to create the power supply for slot number 1. Okay, power supply PS, it means that power supply 300, so we can choose 5M, 2M or 10M to make as the same the hardware of the real PLC. Okay, so right now I will choose 5M. Okay, so I drag and drop here. Okay, power supply 5M. This is the order number of this power supply, and then we can check here 120 until 230 AC volt, then 20 volt DC output 5M. Okay, so the next we must create the CPU, right? To create the CPU, click CPU 300, and then this is all of CPU product that include inside this software. When we install the software, it will create automatically this all these model number. Okay, for example, I choose CPU 314, and then the version 3.3. okay, so I can drag and drop this. Okay, CPU 314, this is the part number, order number and version, and this is the address of MPI, address number 2. It is default. Okay, so after that we will create the IO, right? Example, first create the digital input. Yes, to create the digital input, go to IM 300. Okay, SM300. Here we have DI, DIDO, and AI, also AIAO, and it also have the special module. Yes, special module also. So first I will create the new DI, digital input module, 16-bit 24 voltage. Okay, so drag and drop here. And second, I will create the new DO, digital output module, 16-bit also. Then I will create one more for analog input. And one more for analog output module. Okay, so this is the address. It automatically create. Okay. The next we will download for simulation. Okay. So before download, click save the program first. Okay. And then minimize. Then go to here and then click simulation on off. Okay. So click simulation. Okay, and then click run piece for run the CPU. Then go to option, set PC interface. Then go to PPI. Then go to PLC Sim. MPI. Okay, go here. PLC Sim MPI and then click OK. And then OK again. Yes. So right now the CPU still run. So we will download the configuration first. To download, click this button, download to module, and then click select all, click OK, and click view for view the CPU. Yes, it means that this CPU. OK again. So the CPU will stop and download. Okay, and it will run again. So this is a video how to create the hardware configuration and download for PLC S7-300 to SIMATIC Manager version 5.6. Okay, so right now we already download the hardware to CPU. So right now we will create the program for test. Example, I have one block for OB1, so I will create the sample program. Okay, first create the one button. Example I 0.0. Okay, we can go to check inside the hardware for address. Here, digital input start from 0, and it will has 16 bits. Okay, so and then output will start from 4.5. Okay, so I will start from Q. 4.0. Okay, then download this logic to the CPU again, and we can online for check. Okay, to see the status now is running by simulation without PLC. Okay, so right now I will test this I/O. So first select the IB, right? And then here's the QB4 start from 4, right? Okay, so when I push the I0, the QB4.0 will on. Okay, so it is true. If I turn off, the output will turn off also. Okay, so this is the how to simulation and download the program to the CPU S7-300. So thank you very much for watching my video, and please don't forget like and subscribe my video also, and we will see you next video. Hello everyone, welcome back to my channel again. Today we will continue our lesson about SIMATIC Manager version 5.6. In the previous video, we already learned about how to configuration the hardware like CPU, power supply, digital input, and digital output module. And today I have one topic that related to how to convert from electrical diagram to logic programming of PLC S7-300 via software SIMATIC Manager. Okay, so this is input, so we need 2 input and 1 output for control 1 relay or contactor. Okay, so first let's open the software SIMATIC Manager. Okay, I will use the existing projects for create the logic programming. Okay, so first open the simulation and select to run P. Okay, so let's go to OP1 for existing project. Yes, I will delete this first. Okay, so we need 2 input and 1 output, right? So I need to create 2 inputs. Example I number 0. So I need nominal close contact, right? So I will create the NC. Okay, click here for nominal close contact. So example, I start from I 0.0 and we can create the command for this input. Example, the data is a boolean, right? and we can comment stop. Stop. Okay, stop. And one more input for start, right? This one input also. So I will create the normally open contact, and I will choose input 0.1. So I 0.1, and we can comment. Okay, add symbol, and this is the start button, right? So start, and one more for output, relay output. So start from Q0. I will create the one coil and start from Q0.0. Example, relay number 1. Relay number 1. Okay, and then I have one more for contacts, normally open contact for hold the signal, right? So I click here and then click here and normally open. So we can copy from this and paste to this and drag and drop here. Okay, so right now we already create the logic programming that compare to electrical diagram. Okay, so let's open and let's save and download to our CPU. Before download to our CPU, first go to option and then set PC interface and go to PLC Sim MPI, this one, and then click OK and OK again, and then go to our project and download this logic to CPU. Okay, right now we already download and our CPU is running, so we can online to check the status. So right now the status is on and CPU is running, so we can simulation for this logic. For electrical diagram, we also can simulation. Example, I pre-start. The relay R1 is on, and then hold from this contact to our coils. If I pre-stop, it will turn off. Okay, so let's compare to our logic programming. So I will go to bit and IB, right? IB 0, and one more for QB. Sorry, QB 0 also. Okay, so let's start simulation. Example, I turn on the I0.1. The relay Q0.0 will turn on. Okay, so let's start. Okay, right now the Q0.0 is turned on and hold the signal from here to magnetic coil. If I want to stop, I just push the I0.0. Okay, the output will stop. Okay, so this is a concept how to convert from electrical diagram to logic programming for PLC S7-300 by software SIMATIC Manager. Okay, so thank you very much for watching my video, and please like, comment and subscribe my video also, and we will see you next video. Hello everyone, welcome back to my channel again, General Technology Knowledge. Yes, in the previous video we already learned about how to convert from electrical diagram to ladder diagram and function block diagram. Yes, and today I will have one more topics that related to what is the meaning set and reset function. Okay, so this is the ladder diagram that we will create the program inside software Step7 Manager or SIMATIC Manager. Okay, so this is a set and reset function meaning. Example, if I turn on M10.0, the Q 1.0 will turn on. Okay, let's see the graph. This is the output Q0.1 and this is the input for set function M10.0, and this is the function reset or input for reset M10.1. okay, and this is a 0 or false and this is a 1 or true. Okay, so inside the software SIMATIC Manager there are two options for write the ladder diagram for function set and reset. Okay, so we can write like this, the first method, and we can also write the second method, and the result will get the same as this graph. Okay, so let's go to create the program and simulation. Okay, so I will open the existing project for test and simulation. Yes, please open the simulation first and run the CPU. Select to run piece. Okay, and open OB1. This is the existing project that we already learned in the previous video. So I will create the function set reset, right? Follow the diagram that I already explained. So I will insert one more network. Okay, one more network. Delete this first and insert network. Okay, we can comment example create function set and reset for simulation. Okay, so we can insert the input right first. Example M 10.0, and to get the quite set, please go to the bit logic. Okay, and here is the set function quite, so drag and drop it to here. Okay, and then tie the Q0 1.0. okay, the same as diagram I already explained. And one more network for reset function, right? So I will create one more input for M 10.1. okay, and reset function or reset coil, we can use this one, and this should be the same, right? So Q0 Q1.0. okay, this is the first method that we can simulation, and I will write the one more method for test. Okay, so insert the network more. Okay, for this function we can use this function. Okay, set reset, so drag and drop here. Okay, and this one should be Q 1.0. okay, to be the same, but I can use the Q 2.0 because Q 1.0 we already use. Okay, so this one I need to create one more for M 10.2. okay, for set, and M 10.3 for reset the Q 2.0. okay, so save our project and go to SIMATIC Manager and choose option set PC PG interface, and then go to PLC SIM MPI, PLC SIM MPI, this one, and click OK, and then OK again for simulation. So we can save our project and close first, and then download all, select all, and then click download. Okay, and let's check our CPU. Right now our CPU is running, so let's open the organization block OB1 and then click online. Okay, and I will zoom in. Okay, so right now we already create an online for simulation. Okay, so I will open simulation and test to compare with this one. Yes, this graph. So when M10.0 turn on, the Q1.0 will on. Okay, although it M10.0 turn off, the output still on. Okay, so I will create at the M10, right? Yes, and output Q, right? Q1, right? Okay, so if I turn on M10.0, M10.0 is disabled right now. So MB10, okay, MB10. So I will turn on MB10.0. Okay, you see the Q1.0 is turned on, although I turn off the M10.0. Okay, if I want to turn off the Q1.0, I just let M10.1 is on. Okay, the Q output is off. One more for this one, the same as function. So this one M10, right? And this one for QB2, right? Okay, so I will turn on 10.2. Okay, the output is on. You see, it's true. And I would like to stop Q2.0. I just turn on M10.3. Okay, it's turned off. So this is a concept for create the program set and reset function. So thank you very much for watching my video, and please don't forget like, comment and subscribe my video also to get more notification and more new video. Okay, so we will see you next video. Bye. Hello everyone, welcome back to my channel again. Today I would like to show about how to use the software SIMATIC Manager version 5.6. Continue. Yes, in the previous video we already learned about how to use and simulation the concept of function set and reset. Okay, so today I have one more topic about what is the meaning of function not context. Okay, so this is the sample program that we will create and simulation, and this is a principle of context, meaning of not context. Okay, so this is the input. For example, M10.4. Normally if it on, it will true, right? So the output Q2.1 is off. Okay, so when I turn off M10.4, 10.4, the output Q2.1 will turn on. Okay, turn on for our. So when I let M10.4 on, the Q2.1 will turn off again. Okay, so this is the concept of contact knot. Okay, let's create the program and test with simulation. Okay, first we go to SIMATIC Manager and open the project. Okay, I will choose the existing project that we already learned in the previous video. So open the EP1. Okay. This is the existing project for set and reset. So I will create the new network for create the function node for simulation. Okay, so start insert the new network, and this one I can command not how to use not contact. Okay, so go to PowerPoint again. Okay, so I will choose the nominal open for M10.4. Okay, so M10.4 and choose the not contact, right? So to choose the not contact, please go to BitLogic and then drag and drop the not contact to this network. Okay, and then I will choose the Q2.1, right? Okay, for so Q2.1. Okay, so now we already create the sample program for test. So save our project and download to CPU. But before download, don't forget go to simulation and turn on the CPU. Okay, and then go to set PC interface and go to PLC SIM MPI. Okay, so right now we can download for simulation and CPU stop. Okay, let's clear the CPU and try to download again. I can close this one and download all again. Okay, right now the CPU is running. So open the organization block OP1 again and zoom in. And go to online. Okay, right now we can online, but normally this one is turned on, right? M10.4 is turned on. So we will compare with our PowerPoint slide. Okay. Okay. This is a diagram of principal working of function node. So we will test it. Right now the M10.4 is on, right? So this is 1 or true. So if I turn off the M10.4, the Q2.1 will on, right? So I turn off. Okay, you see the Q2.1 is turned on. But when I turn on the M10.4 again, okay, the Q2.1 is turned off again. So this is a concept of principal working contact node. Okay, so thank you very much for watching my video, and if like my video, please don't forget like and subscribe my channel also to get more notification and new video. Okay, so thank you very much again, and see you next video. Hello everyone, welcome back to my channel again, General Technology Knowledge. Yes, today I have one topic that related to software SIMATIC Manager version 5.6 about principal working of timer. Today I will show the timer S-PAL, and this is the working principle of this timer, and this is the data type that we will use on this timer. Okay, example, the parameter in English we can use in this column, and this is for German. Yeah, we can use this column. Okay, and this is a data type of timer. For example, as it means that set this one, we can use the boolean, and for TV or TW, we can use F5 time. Okay, and preset the value. This is the data type that we will use for this timer. Okay, and this is the sample program that we will create and test for simulation, and this is the principal working and description. We can see on description for the principal. Okay, for example, PAL 5S timer start the specific time if there are another positive edge, mean that set value. Okay, so we can go to create the sample program and test. Okay, so let's go to our program SIMATIC Manager. Okay, I will use the existing project that we already implement in the previous video. Okay, so we can continue to create. So open EP1 and then here we can create like this for test and simulation to see the principle working. Okay, so start from M. 10.5 example, and choose the timer. Yes, this is timer tab. So first drag and drop the timer, and this one we can say T5, and this one follow the principle, can say S5 time, S5 time, 5 sec example, and this one is the result value. So we can say boolean, we can write boolean M10.6 example. Yes, and this one is the output that we will choose it to connect with another device. Example Q 2.2. Okay, so we save the project and go to simulation for start simulator. Okay, and then go to option. Yes, and choose the PLC Sim MPI for simulator. And then select download to our CPU. Okay, right now the CPU is running, so we can online and simulator. Okay. Okay, right now I will choose the M 10.5, right? This one. So when this one on, the timer, the Q 2.2 will on automatically. Okay, you see on, and then after 5 minutes, sorry, 5 seconds, the output will off. Yes, it is a PAL. Again, on. Yes. For example, this one on, then this one is on. It will reset before this timer count. Okay. So this is a concept of principle working for S-PAL timer. Okay. So thank you very much for watching my video, and we will see you next video. Please comment under my video if you have any questions, and don't forget subscribe my video to get more new notification and new video. So thank you very much, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Yes, today I would like to show and share about how to connect program from SIMATIC Manager to WinCC Flexible 2008. Okay. First, I would like to use the existing project that we already learned in the previous video. So let's open the existing project of SIMATIC Manager version 5.6. Okay. In this video, I will choose the simulation from WinCC Flexible to this project. Okay, so we already open, and then we open the simulation tool, then go to option and then choose the set PC PG interface and choose PLC Sim MPI. Okay, so let's open and create the project in WinCC Flexible. So first go to create empty project, but before create the project I will create a new folder for this project. For example, connect, or we can say WinCC 2008. Okay, so we will create the new HMI or new touchscreen from this project. Example, I will choose the basic panel, or we can choose the multi-panel. Yes, or everything that we can choose from this software. Example, I choose the basic panel or mobile panel or what you want. Okay, many types that we can use with this simulation. Okay, but in this project I will choose the touch panel TP 17.7B 6" and color also to simulation. Okay, so click on that and click OK. Yes, and first we must create the new connection for connect from WinCC to SIMATIC Manager. Okay, to create, double click on the connection, and then this name we can choose other name. For example, I choose PLC1, and I will use the S7-200 400. Okay, and we can command it. Example, simulation from WinCC to SIMATIC. Okay, and for this type I will choose this one, and this is the baud rate, and we will connect when we online it as when online. Okay, and this part we must choose the MPI. Yes, and this is the highest station address 31, and number of masters is 1, and this part is a PLC station or SIMATIC station address 2. Okay, after we choose or insert the new connection, we can choose the tag. Okay, to create the tag we must know the tag that we create in the SIMATIC Manager. Okay, so let's open the EP1 example. I chose this one for simulate from the WinCC. Example M10.5 and 10.6, and output is the Q2.2. Okay, so I will create the new input, 2 input and 1 output. Okay, so go to text and double click on text, and we can say set input, right? Okay, set input. So we can write set input, and PLC 1 is the connection that we already created, and the data type is the boolean because it will true, false, or on or off. Okay, and this is the address. Address is M10.5, right? So I will choose M and M10, right? And bit number 5. Okay, or we can comment set input number 1. Okay, and one more for reset input, right? Reset input, right? This one M10.6, we can comment reset input number 1, and one more for output, right? Output Q2.2. So I can write the motor 1 boolean also, and Q, right? No, it will Q2.2, right? 2.2. Okay, Q2 and bit number 2, and then click OK. Example status of motor 1. Yes. So right now we can create the 2 button for set and reset, and one status for motor. Okay, so I will choose the 1 button. Zoom in, right, to be bigger. Okay, example the set button, so we can double click and then go to the text, and we can write set button. Okay, yes, and one more for reset button, right? So we can copy and paste, so copy and paste. Yes, and this is a reset button, so we can write reset. Okay, reset button, and one more for the status of motor, right? So we can write for cycle. Okay, so right now we will configure the button for set. To create the button function, go to event, and then choose the right now we can choose the click. Okay, click it means that we can click, so we can say the invert bit. So take for set, right? So set input, okay, and one more for reset input. So go to click and can say invert bit and bit for reset, right? Okay, and then configure the color of the motor. Number 1, I will choose the text for remark motor 1. Okay, and this color example, when it's 0 it will red color, and when it 1 or it true it will show the green color. Okay, so let's go to color animation and then choose the text. So take motor 1 and the bit example it's 0, it will show red color, and when it 1 it will choose, so sorry, it will show the green color. Okay, so that's all for config the WinCC HMI. So let's go to SIMATIC Manager and then download project to the CPU. Yes, and open it, and online the CPU is stopped right now, right? So turn on it. Okay, right now the CPU is running. So we can start simulation in the HMI. So I save the project first, then go to desktop, WinCC, for example, project 1, tutorial, and then click here for simulation to connect from this software to SIMATIC Manager. Okay, simulation, yes. So right now we can online and simulation. So let's go to test. When I click set button, yes, it will on, and motor will show green, right? Yes, on. If I want to reset immediately, I can choose this button for reset the motor. Yes. Okay. So this is a concept how to configure from WinCC Flexible 2008 to SIMATIC Manager version 5.6. Yes. So thank you very much for watching my video, and we will see you in the video. If everyone have any question, please comment under my video. I will reply soon. Okay, so thank you very much, again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about software SIMATIC Manager version 5.6 connect to PLC S7-300 for control the program and the communication. Okay. So in the previous video, we already learned about how to communication between software TIA version 15.1 to the PLC S7-300. Okay. So today we will continue for the how to communication between software SIMATIC Manager version 5.6 to PLC S7-300. Okay. So in here I will choose the adapter USB A2 also, the same as the TIA, yes, that we already learned in the previous video. And here is the I/O, yes, that we focus on DI, DO, AI, and AO. So we will continue, yes. So we must create the hardware configuration from our software and then download to the hardware. Okay. So let's go to our software, SIMATIC Manager, yes. Okay, here is the software SIMATIC Manager that I already installed in my PC, yes. So let's open it. Okay, and create a new project. Before create the new project, let's go to create a new folder. Example S7 PLC S7-300 VR SIMATIC. Okay. So create a new project. Example training, like this, and browse to find the folder that we already created. Yes, here is the folder that we already created. Yes, click OK and then choose OK. And first we must check the communication between our PC to the PLC. So right now I will insert the USB cable that connected from PLC to my PC. Okay. Okay, connect. And make sure the driver is already installed, yes, in the computer. So let's go to check by go to manage, go to device managers, yeah, and click the SIMATIC net. And here is the USB adapter driver that I already installed in my PC. Yes. To check communication between our computer to the PLC, okay or not, let's go to option and then set PC interface and choose there, yes, choose USB adapter A1 sorry, A2 and auto, yes, to here, and then property, and then let detach, yes. Okay, right now it found, yes, MPI adapter. This is a baud rate, yes, transmission rate, and this is address, yes. So if it show like this, it means that we can communication between our PC to the PLC. We are MPI adapter. Okay, so let's click OK and click OK again. So right now we must create the hardware configuration, yes, before download to the PLC from the SIMATIC Manager. Okay, so right click in the project and then insert the new object, and then choose the SIMATIC 300 station, yes, because right now we use SIMATIC 300 PLC, yes. Okay, and then click double click the SIMATIC 300 and double click on the hardware, yes. So first let create the rail or backplane, yes, we can say rail or backplane. Let's go to SIMATIC 300 and then go to rack 300, yes, and click drag and drop the rail from right side to left side, yes. Okay, so normally we must create the power supply for the CPU, right, that it will convert from 220 to 24 voltage DC to support the CPU. Okay, so let's go to the PS. It means that power supply. Example, I choose this one, PS 10M, yes, it means that 10 ampere, yes, and go to the input and output, right, for I/O, but we must create the CPU first. For CPU, this is a serial number of the CPU, and this is a CPU name 3512DP, right? So go to the CPU and then go to the 315, yes, and then go to the serial number, yes. We must create the serial number to be the same, otherwise we cannot download to the hardware, yes. So 315 2AH 14, okay, 315 2AH, yes, 2AH 14 version 3.3, and then drag and drop to the real, yes, and then click OK. Yes, in the next step we must create the DI, right? So this is a serial number of DI 3211BH02, yes. So let's go to the SM300 and then go to DI and choose, yeah, find the serial number to match with this one. So 3211BH02, okay, 1BH02, yes, this one. You see here is the serial number, so we must choose to match with the hardware, yes, our hardware. So this one, drag and drop to the rail. The next step, we must create the digital output, right? So 3221HH01. Okay, so let's go to DO, yes, 1HH, right? BH 880 00, okay, 01. This is a 00. Yes, this is a 01. So drag and drop to the real, and for slot number 6 is the same, right? Here, so just drag and drop one more, because digital output we have 2 cards. Yes. In the next step, let's go to the AI. So 3317KF, yes, 02. Go to tab AI. Yes, AI. So 3117KF02. 3117KF 02, right? Or 01. 7KF02. 7KF02. Okay, this one you see 7KF02. Okay, drag and drop to the real again. And the next, create the last card, yes, for analog output. So 58F00. Okay, so let's go to tab AO, yes, and then find 58F00. Okay, so this one you see 58F00. Drag and drop to real again, and then save our project. Yes, so right now here is the address. It will generate automatically for the digital input. It will start from I0.0 and earn I1.7. yes, it is 8 bits, totally 16 bits. And for digital output, it will start from Q4.0 until 9.7. It is 2 cards. This is analog input, yes, and here is the analog output address. Okay, right now let's go to save our program and then download hardware configuration to the CPU by click this button, yes, and then select all and then click OK. Okay, so here we click views for make sure that we can communication between our computer to the CPU. Okay, so right now we must download. Okay, and then click OK. So when we confirm click OK, the CPU will stop. Okay, because we just download the hardware configuration. So click download. Okay, you see the CPU is stopped right now. Yes, and I will run again because we already download. Okay, the CPU is restart. Yes, and then run. So we must create one program, sample program for test to make sure the hardware configuration is okay or not. Okay, so let's close here. Yes, and then go to our block, right? And then go to the EP1 and choose the ladder or structure text or function block that you want. For me, I choose the ladder because it's very easy to create the sample program. And this is a block name, block comment. Yes, you can comment anything. Yes, just click OK. Okay, so right now I will create sample program for test. Example, stop. Yes, start. Yes, and then coil. And this one I would like to hold the signal. Yes, here, and I will create one more for output. Yeah, and one more for output. Example file output. I will turn on file output one time. So let's click output. Yes, 3. Yes, just 3. One more. Okay, so let's go to the hardware configuration. Yes, because we must create to be on the output after I press the switch. Yes, so output it will start from 4.5, sorry, 4.0. So let's go to this one example 0.0. Yes, something. This one 0.1. Yes, the same RTIA that we already create. And this one example Q 0.0. Yes, and this one Q 0.0 also, Q 0.1, Q 0.2, Q 0.3, and Q0, so 1.7, the last one. Yes, of this card. So save our program and then download to the CPU. This one no need to stop CPU because we don't download hardware configuration. Yes, so let's online. Okay, right now we can online, and right now the CPU is running. Yes, and I will turn on the button. Yes, for test the output. So when I turn on M0, so normally we can do like this. Go to the PLC data monitor. Yes, can say we can write M0.1. Yes, and then online, and then write this one to 1, and then click this one. Yes, you see the button is on. Yes, and this one should be start from 4, right? Because this one 4.0. Yes, so I will change this one to 4, 4.0, 4.1, 4.2. Yes, 4.3, and 4.7. Okay, so let's save and then download again, and online again. Yes, right now you see the CPU is running, and digital output is turned on also. Okay, so it means that we can communication and test with our software with the hardware. Okay, if we want to create one more, we just choose this and then go to the output more Q5.7, right, the last card, and then save our project and download again, and online you see. You see the last points of digital output is turned on. Okay, so this is a concept how to configure the software SIMATIC Manager version 5.6 to PLC S7-300. Okay, so if everyone have any question, please drop comment under my video. I will reply soon. Okay, so please support me by please like, share, and subscribe my channel also to get more notification and more new videos that I will create step by step. Okay, so thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to share about how to upload program from PLC S7-300 using software SIMATIC Manager version 5.6. Okay, so in the previous video we already learned about how to uploading the program from PLC S7-300 by using software TIA Portal version 15.1 by using the USB adapter and connected to the PLC CPU S7-300. Okay, so let's go to our software to uploading the program. Yes, in this case I will use the PC Adapter USB A2 also. Yes, that I already connected from the PLC to my computer. Okay, so let's go to our software. Okay, so here is the software SIMATIC Manager that I already installed in my computer. Okay, so to upload the program, first create a new folder. Yes, example uploading PLC S7-300. Yes, like this. And let's go to open the program SIMATIC Manager software. Yes, and let's choose the file new or just click here to create a new project. Yes, So example, the project name here, I will choose the PLC S7-300 backup. Okay, like this. This name everyone can use any name, no problem. Yes. So browse to choose the new folder that we already created in the desktop. Yes. So here is the folder. So select here and then click OK. And then click OK. Okay. So first I will connect the USB adapter to my computer. Okay. So let me connect it. Okay. And then choose the connect visual machine because I use the VMware player. Yes. So let's click OK. And then let's go to check our connector. Yes. Let's go to manage and then go to the device manager and let's check it. Yes. Here is the driver. Yes. Let me disconnect and recheck again. Okay. It not show the driver. Let me connect again. Yes. Okay. Right now it show the connector again. Show the driver. Yes. It means that we can connect from the PC adapter USB to our computer. Okay. So let's close it and then let's go to our software. Okay. Right now let's click PLC and then click upload station to PC. Okay, to upload the program. Again, let's go to the PLC tab and then click upload station to PC. Okay, so let's click it and wait a moment. Yes, and let's select local for target station. Yes, and click view. Okay, right now it found one CPU model 315 2DP. Yes, SIMATIC 300. Yes, CPU. This is a CPU model. Yes, and then click here and then click OK. It will back up automatically the program. Yes, that has in the CPU. Okay, let's go to check by press here. Right now it will back up all for configuration like the hardware configuration. Yes, you see here is the CPU name, here is the power supply, and here is the digital input, digital output has 2 cards, and analog input 1 card, and also analog output 1 card. Okay, so it will back up both hardware and program also. Let's check the blocks. Yes, you can open block for check. Yes, and we can online to check the status of the program. Yes. Okay, and we can also forward some signal like 420 and then can modify. Yes, to on the output for test, or we can do like this. Go to monitor. Yes, example Yes, this one. 0.0, 0.1. Also Q4.0, Q4.1, Q4.2, Q4.3, Q4.7, and Q5.7. Yes, because we can download, yes, and online, yes, and we can fork the signal. For example, 0.1, we can fork this signal, yes, to let output on, and we can stop also by forcing this one to 1. Yes, okay. So this is a concept how to uploading the program from PLC S7-300 by using SIMATIC Manager version 5.6. Okay, so thank you very much for watching my video, and if everyone have any question, please comment under my video. I will reply soon, and I would like to request all of you to like and share and also subscribe my channel to get more new notification and new video that I will create it step by step. Okay, so thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to configuration PLC S7-300 hardware by using LAN cable and connect from the PC to the CPU 314C 2PN/DP. Okay, and I will choose the SIMATIC Manager version 5.6 for make the configuration. Okay, so let's go to our software. Here is the software Step7 SIMATIC Manager version 5.6 that I already installed in my PC. Okay, so to create the hardware configuration, let's open it. First, go to create a new project. So this is a project name, so I can write S7-300 LAN config. Yes, and I will create a new folder for this project. Example PLC S7-300 LAN. It means that use LAN cable for configuration. Yes. And browse to choose the folder that we already created. Yes. Here is a folder Yes. And I will create the new object. Yes, SIMATIC S7-300 station. Yes, and go to hardware and go to the SIMATIC 300 and choose the SM, the rack, right? And choose the real. And then let's go to CPU. Yeah. C. Yes. 2PN/DP. Yes. This one. Version 3.3. Actually, the version is wrote on the nameplate of the PLC CPU. Yes. So I drag and drop the CPU to the rail. Yes. And this is the IP address of the PLC. Yes. And then let's click OK. Here is the address that it automatically maps for us. Yes. It means that have the digital input, digital output, analog input, and analog output also. And this is a counter, and this is a position control. Yes, include also. So right now we already create the hardware configuration. So let's save our project, and then let's go to the communication between our PC to the PLC. So right now I already connected the LAN cable from the PLC to my PC. Okay, so let's go to set. So we can go to option and then set PC interface. Okay, and then we will choose the network adapter. Yes, this one, and choose the diagnostic for test. Yes, it's so like this. It means that we can connect it from our PC to the PLC. Okay, so let's click OK and then click OK, and then go to the hardware configuration and then download, select all, and then click OK. Yes, wait a moment for connecting from our PC to the PLC CPU. Okay, it will automatically found the PLC. Yes, so you see here is the PLC, and here is the address of the CPU. Yes, here is the CPU name. Yes, 314C PN/DP SIMATIC S7-300. Okay, and we can click view, and then click OK. Yes, click here and then click OK for downloading. Yes, and then OK, and click yes to start the CPU. Yes. Okay, so right now we already connect and config and also download from our PC to the PLC. Okay, and this is automatically address that map. Yes, and let's go to create sample program for test. Yes, so double click at EP1 and then go to create the language. Right now I will choose the leader. Yes, yes, and I will choose the NO, NC, NO, and COI. Yes, and one more COI. Yes, one more COI. Yes, like this. I will choose start for outputs. Yeah, so we'll choose the like this and choose the NO contact. Yes, example this one M0.0 for stop. Insert symbol. Yes, example stop button. M0.0. Yes, and this is for start button. M0.1. Yes, and this is a output number 1. So output number 1, it will start from, yes, go to hardware and check here. Here is the address. Yes, so output number 1, it will start from Q 136.0 until 137.7. okay, 16 bits. Yeah, so I will choose the Q 136.0. Yes, and here is the Q 136.7, and this one Q 137.0, and one more Q137.7. okay, and this is, we can hold the signal. Yes, we can edit some symbol like output 1, output 2, sorry, output 8. This one output output 9. Yes, and this one output 16. Yes, output 16, and then save our project and then download. Yes, download and then online. Yes, so right now we can online, you see. Yes, so if I force signal. Yes, example, go to the PLC. Yes, monitor and modify, and then M0.0, M0.1, Q136.0, Q136.7, Q137.0, and Q137.7. Okay, so if I would like to start, yeah, I let M0.1 is turned on. So online first, and then write to 1. Yes, you see the output is turned on, and I will let you see the PLC. Yes, right now you see the bit number 1, number 7, sorry, number 8, number 9, and number 16 is turned on. The output module, yes. So if I would like to stop, I just for this one to 0, and then for this one to 1. Yes, it will stop. And you see the PLC is stopped also right now. You see the output is turned off. Okay. And I will remove this one to 0. Yes, to be a normal circuit. Yes. So this is a instruction how to configure the hardware configuration of PLC S7-300 by using Ethernet LAN cable. Yes, with CPU 314C 2PN/DP. Okay, so thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to please like, share, and subscribe my channel also to get more notification and more new video that I will create step by step. Okay, so in this time I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again. General technology knowledge. Yes, in the previous video we already learned about uh, electrical diagram vs ladder logic diagram using SIMATIC Step7 version 5.6. Okay, so today I have one more topics that related to electrical diagram vs ladder logic, and one more for function block diagram. Okay, so in these two sections we already learned about the electrical diagram and ladder logic. So today I will add one more for function block creation. Okay, so they are similar for this one and this one, and also this one. So if we create a function block, we can apply to all this. Okay, so to create function block, let's go to our software SIMATIC Manager. Okay, so this is a software SIMATIC Manager. So let's open. Okay, and then create a new project. I will create the one more for folder. Example FB block creation. Okay, so this is a part 2 FB block. Okay, so click browse and then to choose the new folder that we already created. Okay, so first create the new SIMATIC station. I will choose SIMATIC S7-300 station, and then go to the hardware configuration that we already learned in the previous video. So I will go fast because we already learned. So first go to the rack and then create the new power supply, right? So create the new power supply and then create the new CPU. Example, I choose the CPU 314 for this project, version 3.3. Okay, then I will create the I/O module. First go to the digital input module. Second, go to digital output module and also analog. Just create it. Yes, analog input, analog output. Okay, and then go to simulation. Click simulation. Okay, and then go to the run P. Then go to the step 7 set temporary project. Go to PLC Sim MPI and then click OK. Okay, right now we already open the simulation and then we will save the project and go to download here. Select all and download to the CPU. Okay, and then close the hardware. Okay, right now CPU is running, you see. So to create the function block, go to the block first. Here is the block and right click, create the function block. Okay, insert new object and function block. Example, function block number 1, FB1, and I will choose the ladder language for create the function block and then click OK. So let's open the FB1 and then zoom out, zoom in for easy to look. So first go to input because we have two input, right? and one output for control. So I need to create the two input. Okay, for input number 1 example, I choose the stuff. Okay, the data type boolean address 0.0, and then command, we can say stop command. Okay, stop command. One more input, right, for start, and then start command, stop command, stop command, right? Okay, and one more output, right, for command start. Okay, so I can say output, and then for example, command start motor. Okay, so right now we already create the variables for input and output. Okay, so let's create the function block. So I will choose the normally close, right, for stop. So I can say stop. Okay, this one, and then one more for normal open. So I can say start, and one more for output, right? So output, I will choose the quiet for output, and then I can say output. Okay, I can say output, and then we have one more for hold the signal, right? So I can say, I can use this one, and then choose the NO, and this one should be output. Okay, so right now we already created the function block, so let's save, and then we will download to the our CPU. Okay, so we will call this block to the OB block for testing. Okay, this network number 1 example, motor control 1. Okay, so I will call the FB block number 1 to this network. So to call, just drag and drop the block. Yes, so we will saw the two output and one two input and one output. Okay, for example, DB1. Yes, and this one we will assign the address for input. Example M0.0, M0.1. Example, the output start from Q0.0. Okay. Okay. So this is a function block that we already created. So save the project, and then we will download all this block to the CPU again. because we just add and modify the block. So select the block, all blocks, and then click download and choose all. Yes. So let's check our CPU. Yeah, this CPU right now is running, so we can open the EP1 and then online to check the status. Yes. So we can test it. Example, start from 0.m0.0. So if m0.1 on, the output q0.0 will on. Okay, so I will test. Okay, you see the q0.0 is on when m0.1 is on. If I want to stop, I just turn on the m0.0. Okay, so it stops. So it is the same the ladder, but if we create the function block, we can apply to more block without create the same time. Okay, so if we want to use this block for control the motor number 2, we just add the network number 2 and then drag and drop this function block to this one, and then for example db2, and for example start from i0.0 for stop input, and i0.1 for start input, and q 0.1 for motor number 1. So we can use it. Okay, we must download again because we just add the new block. Okay, CPU is running, so let's check the block again. Yes, right now we have 2 motors. Okay, I will command this one, motor control number 2. Okay, so if we have the block, the sample block mean the library block, we no need to create more the ladder, we just drag and drop to use. So let's test. For motor number 2, start from i0.0. So I will change this one to okay, we can add one more for testing, IB. So it start from 0.1. So i0.1 on. Yes, the Q 0.1 is on. If we want to stop, we just turn on this one. The motor number 2 is stopped. Okay, this one also on. Okay, so this is a concept, convert from electrical diagram to ladder diagram and function blocks diagram. Okay, So thank you very much for watching my video, and please don't forget like and subscribe my video also to get more new video that I will create next time. Okay, so thank you very much again, and see you next video. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about software SIMATIC Manager of PLC S7-300 with WinCC Flexible 2008, how to create the function that we call FC. Yes. Here is the sample block that I already created for simulation with PLC S7-300, and the first page or screen that created by WinCC Flexible 2008. To create the FC, first we need to create the hardware configuration, and then we will create the FC function, and then we will create the screen by using WinCC Flexible 2008. Okay, so let's go to our software to create it step by step. Yes, let's go. So first we need to have two software. The first one is SIMATIC Manager, and the second one is WinCC Flexible. Right now I use SIMATIC Manager version 5.6 and WinCC Flexible 2008 CV page 5. Okay, so first open SIMATIC Manager, and then create a new project. Yes, and create the folder, example FC. Yes, FC tutorial, and browse to find the folder that we already created on desktop. Yes, FC, and then click OK. So first we need to create the hardware configuration. So create the SIMATIC station 300, example PLC 1, double click and double click on hardware, and then choose the SIMATIC 300, and then go to the rack and create the rail. Yes, totally it has 12 slots for this rack, and then I will create PS, example power supply and CPU. Right now I use CPU 314C 2PN/DP. Yes, version 3.3. Drag and drop. Yes, and click OK. And this is the IP address of this PLC, and here is the subnet mask. So click OK. Yes. So let's see here. The output is start from Q136, and input also start from 136 also. Yes. there are 24 inputs and 16 outputs. Yes. And for analog and counter and position control, we not yet use. So we use only output and input. Okay. So we will download to simulation. To download to a simulation, please click simulation. Yes, and then click run and go to our hardware configuration and click download. Yes. Start the CPU. Yes, restart the CPU. Okay, so right now we already download hardware configuration to simulation tool. Yes, PLC sim. And then we need to create the block, right? So right click and go to insert new object and create the function, right? FC. Example, motor control. Yes. FC name is motor control, and I will choose the ladder language. Actually, we can use structure text language, ladder language, and function block language. So right now I will use ladder language, and then go to FC1 and double click on FC1. So we need to declare the inputs and outputs, right? So example input, I have start, stop, overload. Yes. And it is the boolean. Example command start, command stop, motor overload. Yes. And for in output I have only one. Example for Q, or we can write right. Yes, it is common start output. Yes. So after we create variables, we can go to the logic and then create the logic, stop, start, and coil, and also hold the signal or drive, right? So this is a stop, start, yes, and here is drive, right? So it's very simple for create the FC, yes, function. So that's all. So if motor overload, I will use NC for cut the circuit, right? So overload. Okay. So save our program, and we can write command a little bit. Control function for control the motor. Yes. So save again and then go to OP1. Yes. And I choose the ladder also for OB1. Example motor 1, control motor 1 using FC. Function Yes. So to use the FC that we already created, let's go to this tab, FC block. Yes, we will saw the FC1 that we already created in the block. Yes, so drag and drop here, and then we can use example M 0.0, M 0.1 for stop, and example I start from I 136.0, right? Hardware configuration here. Yes, start from I 136.0. Yes, and for output is Q 136.0 also. Yes, so this is the FC that we already created, and then we call it to use. So save, and then go here, and then select all, and then download again. Yes, the CPU will restart for simulation. Yes, and then go to EP1 and open the online. Yes, online. So actually we can use like this for test. Go here, and then this one is MB, right? So MB0. So if I would like to start, I just press M0.0, right? So M0.0 on. Let's see the status. So QB 136, right? Sorry. So here is on also, and then let stop. Yeah, it will stop. Run, and if motor overload, it will stop also. Yes. I, right? This one. So we need to create the touch screen or HMI for control this motor, right? Yes. So let's go to our software WinCC Flexible to create the screen for control the FC. Okay. So open WinCC Flexible. Right now I use 2008 series page file. Yes. And create the empty project and go to panel. Right now I will use TP170B 6 in color. Yes, because it match with the hardware of my touch panel. So first we need to create the connection. So double click on the connection, and then write the name here, example HMI1, and this is a driver connection that we want to connect. Right now I will connect to SIMATIC S7-300. Yes, and then I will choose the Ethernet. Yeah, and here is the IP address of computer, example 192.168.0.0.253. Yes, and here is the IP address of PLC. So 192.168.0.1, right? Check here, IP address of PLC. Yes. go to communication. Yes, Ethernet, right? Because we already created for Ethernet. Yes, for the CPU. Okay. So 192.168.0.1. Yes. And then we will create the text, right? The next step, we will create the text. So for text that we will create here, first one is M1, example M1 start, right? It is the boolean and start from M0.0, right? So choose M0.0, yes. M1 stuff, M0.1, M1 overload, I, right? 136.0, right? And we also have the drive, right? M1 drive. So Q 136.0, yes. And we need to create the command example start for motor M1, stop for motor 1, motor 1 overload, right? And motor 1 drive. Okay, and then we will create the screen, right, for control. So I need two buttons. First one is start button, right? So start. Maybe adjust the font, yes, a little bit to be 18, yes. And color we need to change to be red color. Yes. So I will copy one more for stop, right? So this one is stop and should be a red color, yes. And we need one motor, right? So go to graphic and then go here, go to the runtime color, symbol factory graphic, and then go to here and then choose the motor or fan that we want. So example, I use motors, yes. I will choose one more motor, yes. Example, this motor, yes, drag and drop. So this is a motor 1, right? So create the text motor 1, and I will adjust the font a little bit to be 20, yes. And change color to be blue. Property change to blue, yes. and also adjust to be center, yes. And I will use the rectangle for show the status of motor run or stop, yes. So I will choose red color, yes, like this, and then go to here for button start, go to event and then freeze. So when freeze, it will set, right, set bit M1 start, right, and when release, I will reset bit M1, yes, sorry, M1 start also. And for stop, I will choose the freeze also. So set bit M1 stop and go to release, reset bit M1 stop also, yes. And for the condition, yeah, I will use the animation and go to the text, yeah. So M1 dry and then choose the bit, and if the condition is 1 or condition is true, I will change the color to green color, yes, and save the project of WinCC and go to the desktop, right? So FC HMI example. Okay, so simulation. Okay, so we can online and start and stop. Example, I press start. The motor is run, yes. When I press stop, the motor is stop, yes. If we press start, let's see M0.0 is turned on, yes. Stop M0.1 is turned on, and then motor is stopped. Okay. So here is the basic of how to create the FC function, yes, for control the motor on Step 7 SIMATIC Manager and WinCC Flexible. So thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And it's just example, yes, and I'm also sorry if I have mistake in this video because my English is not so good. So in this time, I would like to say thank you very much again, and don't forget like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about how to use SIMATIC Manager to create FC that we call function to control another motors that we want to control. Okay, so I would like to review the previous video or previous lesson that we already created the one block for FC1 to control the motor such as start, stop, and the condition of the motor. for run, let's see the green color, and for stop, see the red color. By using SIMATIC Manager and WinCC Flexible software. Okay. So today we will duplicate or copy for FC1 to apply another models. Yes. By using SIMATIC Manager and WinCC Flexible 2008 also. Okay. For SIMATIC Manager, I will use version 5.6 and WinCC Flexible 2008 series page 5. Okay. And after this one complete, we will connect to the real PLC for test and simulation by start and stop to the PLC S7-200. Okay. So to duplicate the object or models, another model by using FC1, let's go to our software SIMATIC Manager and WinCC Flexible. Okay, so let's go together. Okay, so first open software SIMATIC Manager version 5.6. And I will use the previous project, yes, that we already learned in the previous video. So let's open simulation, yes, okay, and run the CPU, yes, and download this one to the CPU because we already learned in the previous video. So for hardware configuration, no need to create again because we already created in the previous video. Okay, so this is a OP1 and only one model that we already created in the previous video. So today we will add 3 more models, yeah, for using this FC1 to apply another model. Okay, so to create the motor control, yes, let offline and then create the new network, yes. Example, this one motor number 1, yes. Example, this network is motor number 2, yes. Sorry, motor number 2, okay, number 1, and this one number 2, yes. And let's go to the FC block tab and then drag and drop this FC to this network, yes. And let's see here, motor control, the same as this block. And we need to put the address for start and stop the motor also. Example, this one, it will start from M 0.2, yes. This one M 0.3, and this one I 136.1, and this one Q 136.1, yes. And we will got this motor. Okay, so we can save the project and then download to the simulation, yeah, and we will got the motor number 2. Okay, so for number 3 and number 4 we can copy like this, yes, yes. We can also copy like this and change this one to 0.4, yes, 0.5, this 1.2, yes, this 1.2, and this one should be motor number 3, right? show motor number 3. Yes, and we will copy one more for motor number 4, right? So insert network, and then we can also drag and drop from here, and then also copy from here. Okay, so copy and then paste, and change this one to 0.6. Yes, 0.6, 0.7, 0.3, 136.3, 1C3.3. Yes, we will got motor number 4. Okay, so we can copy Control C and Control V to this one, and then we can save and then download to the simulation, and we can online. Yes, actually we can simulation from here. Example, we would like to control motor number 4, so we can go here and then go to M0.6. Yeah, this one 0.6 start, right? So if I press MB 0.6, the Q 136.4 will start, and if I would like to stop, I just push this one, it will stop. Okay, but right now we will go to WinCC Flexible to create the touch panel for control this motor. Okay, so let's go to WinCC Flexible. Yes, okay, so let's open WinCC Flexible 2008. Yes, so with page 5 right now. I use with page 5, and then go to the FC HMI. Yes, FC HMI, that it is the previous project that we already learned in the previous video also. Yes, so we will go to text to create one more text for motor number 2, right? So we can copy from here. Yes, select and then right click and then copy, and then right click and then paste. Yes, we will got 4 text more for motor number 2. So let's check the address. Yeah, for motor number 2, it will start from M 0.2, 0.3. Yes, like this. So this one for start, right? For start M0.2, right? So M0.2, yes, for start. So M2 start, M0.2, M2 stop, M2 stop, right? M0.3, M2 overload, M0, sorry, I0, I136.1, and then M2 drive, right? Q 136.1, and we will rename this one also for motor number 2. Yes, motor number 2, motor number 2 overload, motor number 2 drive, right? So we can copy to another motors that we want. Yes, so I will create for motor number 3. So right click, copy and paste. Yeah, and change this one to motor number 3. Yes, so this one should be number 4, 0.4, 0.3.2, right? 136.2 also, and this one should be motor number 3 underscore start, motor number 3 underscore overload. Yes, number 3 for dry. Okay, and we can rename here, yeah, for motor number 3. Yes, number 3, motor number 3, number 3 also. Yes, number 3 also. So another one, the last one, so copy and then paste also, and change to motor number 4, the last one. Yes, so if we can do this for motors, we can apply to another motor that we want by using the FC1 that we already created. Yes, so it's very easy for create FC. It's similar to big class and object. Yes, because we create only one, so we can apply to another blocks that we want. Yes, so this one M4 start, right? So let's check again to make sure. M4 start 0.6. Yes, for start 0.6. Stop 0.7, and for this one 0.3. Yes, Q136.3 also, and this one should be number 4 also, this one number 4 also, and this one number 4 also. Yes, okay, so that's all for create the text for these motors. So we will create the screen, right? So this one, screen number 1, so I can rename to screen M1. Yes, and then I can copy. Yes, so right click, copy, and then paste. Yes, so rename to be motor number 2, and then double click for motor number 2, and then change this one to motor number 2. Yes, very fast. This one, go to event and then change to M2 start. Yes, and release M2 start also. For this one, please M2 stop. This one M2 stop, and this one M2 condition, right? So we can go to the animation and then only change the text. Yeah, okay, and then we will go to copy for motor number 3. Yeah, and paste. Yeah, paste for motor number 3, and then rename to M3. Go to double click and then change this one to motor number 3. Yes, go to general, motor number 3, and then this one, go to event, please change the name, the tag name to motor number 3. Yes, release also. So it's very easy to create the format. Yeah, if we know how to create it, we can create another program to control another objective that we want. Okay, so it's just example. If everyone would like to know many function, yes, we can try together by using this simulation. Yes, so the last one I will copy and then paste for peg of motor number 4. Yes, this one. motor number 4, yes. So this one, go to tab general, change this one to 4, and then go to start, go to event, freeze, change this one to 4, yes. Because we already rename or created the text, yeah, the same format, so we just change like this. It's easy to create, yes, and spend a little bit time for create it. Okay, yes, and this one for condition, yes, go to animation and change this one to 4, yes, yes, that's all, and then save the project. And we need to call the screen, right, from motor number 1 to motor number 2 to motor number 4, right? So I will use the one more button for select the screen, right, or call the screen. Example, this one, motor number 1, yes. So example M1, yeah, call M1 screen. So I will adjust the font a little bit, yeah. Go to property, go to text, and then adjust the font, yes. Font size, example 16, yes. And go to the event, yes, and go to click, yeah, or freeze. Okay, I will use click and then go to activation screen, yeah, choose this one, yeah, activate screen, and then example activate screen, this screen name, right? So screen 1, yes, and then enter, yes, screen M1, right? So screen M1, and then please enter, and one more for M2, right? M3, yes, and M4, right? So we have totally 4 pegs for M1, M2, M3, and M4, right? So we need to have the 4 button also, yes. So I will change this one to M2, yeah, it means that call screen number 2, yes, and then go to the event, and then change this one to M2, yeah. This one is the screen name, yeah, let's see here is the same, yeah. This one for M3, yes, change to M3. This one M4, go to event and then change to M4, yes. So I will adjust a little bit to be center, right? Okay, like this. Adjust this one to be like this, yes. And then I will copy and paste this button to all screens, right? Because we need to call from one screen to another screen, yes. Copy and paste, just paste, yeah. And just paste, yeah. And save the project, yes. And we can simulation, yeah, for control the FC, yes, link to SIMATIC Manager, yes. So let's see here, it is the M1, right? So if I press start, M1 will turn on. I go to screen motor number 2, yes, this one, let's see here, I will click start, yeah, M2 start. I will go to another FC, yes, please M3, yes, M3, why not start M3? Let's check the address again for text, yeah, M0.4, Oh, this one should be like this. Incorrect. Yes. So FC motor number 3, 0.4 is start, 0.5 is stop. So let's check the text. M3 0.5 for start, this one, right? 0.4 start, right? 0.4. So I will change to start for motor M3. 0.4 stop 0.5. Yes. Okay. And then save and then simulation again. Yes. I'm also sorry for my mistake. Yes. So let's go to motor number 3. Yes. Right now we can start and stop. Yes. And then go to motor number 4. We can start. Yeah. Let's see here. So right now all motors is running. Yeah. Let's see. Yes. Motor number 2, right? I will start again because we confuse the text. Yes. So it's very easy for create the FC for copy and paste. Just copy and paste for library. Yeah, it is the same as the library or class and object for apply to another objects that we want to control. Okay. So it is just example for let everyone know about how to create the FC and how to copy to apply to another motors that we want. Okay. So thank you very much for watching my video. And if everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to read data from encoder by using PLC S7-300 CPU 314C 2PN/DP. Okay. This is an encoder and I already connected the cable for supply 24 voltage, positive, negative, and this is a signal from encoder for A phase and B phase. Okay. And this is the PLC S7-300 that I already connected the cable from encoder to this card. Okay. And here is the connection. Yes. I would like to explain a little bit for connection. For encoder, you see A, B, it means that we can connect the signal from A and B from encoder to this terminal. And for supply, we can connect from power supply that jump with the 1L plus and 1M. 1M means that minus or negative, and 1L plus it means that positive or plus. Okay. Okay, to read the data from encoder, so let's go to our software to create. Yes. So first open SIMATIC Manager version 5.6. Right now I use this version, and let's create a new project. So new folder, example S7 PLC S7-300 encoder. Yes, and then go to SIMATIC Manager, create new project, S7-300 encoder, and browse to folder that we already created on the desktop. Yes, this one, and then click OK. Yes, and go to SIMATIC 300 station, hardware configuration. Yes, double click hardware and then go to the SIMATIC 300 and then go to the rack and rail, insert the rail. Yes, and let's go to the CPU. Yeah, CPU 300, and right now I will use this one. Yes, 314C 2PN/DP version 3.3. Yes, let's click OK first, and then go to hardware configuration. Yes, here counter, you see. So to enable the counter operation, high speed, it means high speed counter operation. Yeah, here is the description. You see there are 4 channels for counter in this CPU that is built in the CPU. Counting and frequency measurement with 60 kHz pulse. Yes, with modulation with 2.5 kHz. Yeah, switching frequency, counting frequency. Okay, so we can use 4 channels in the CPU. And to enable the counter, yes, there are 4 channels, you see. So we can select one by one to enable this counter. So first I enable the channel number 0 first, and then go to count continuously. Yes, connect here and then click OK. To enable another counter, you can select number 1 and then choose the count continuously the same. Yes, channel number 2, yes, count continuously, and channel number 3, count continuously also. Okay, and here is the address, yes, of counter. Yes, it starts from I816 and earn 831. Okay, and when we configure the block, we must convert this one to hexadecimal. Yeah, example, here is the decimal address, right? So decimal 816, yeah, example, and go to hexa, you see 330. Okay, so click OK and then go to download. Yes, download the setting to the CPU. So wait a moment for connecting from SIMATIC Manager to PLC via LAN cable. Yes. So wait a moment. Okay, click view. Okay, so right now we found one CPU, and here is the MAC address, and here is the CPU. Yes, you see 314C2PN/DP SIMATIC S7-300. Okay, and click OK to download to the PLC. Yes, and then go to block. Okay, so open the OB1 organization block and choose later. So right now I will add 4 counter. Yes, and I already connected the cable from terminal that I show on the slide to the other counters already for channels. Yes, so I will insert network, 4 network, right? Okay, one network is a counter. Yes, and go to library and go to standard library, and then go to system function block. Yes, and I will use this one. Yes, SP47 for counting. Yes, so drag and drop, drag and drop, drag and drop. Yes, so there are 4. Yes, or we can use like this. Yes, yes, like this. But actually I like to use like this. Okay, so I delete this first and then use like this. Okay, like this. For this one example, DB1, DB2, and this one DB3, DB4. Yes, and here is the channel number, so it starts from 0, right? 1, 2, and 3, right? Okay, totally 4 channel. And the address, yes, let's see the address. It will start from I, right? I 816, right? And we can see here 816 is 330 for hexadecimal. Yes, so we can use W 16 W 330, right? Okay, and for channel number 2, sorry, channel number 1, it will start from 820, right? You see here is 816, and there are 4 input for the rank, right? So it will start from 820, right? So 820 334. Okay, so we can copy, and then here 334. Yes, and for channel number 2, it will start from 8, right? 824, right? 824, and then HR, yes. So 33H, yes. And the last one for channel number 4, it will start from 828, right? So 828, it will be 33C, right? So 33C. Okay, and we need to insert the switch gate. Yes, example M10 100.0. Yes. Okay, and this one also M 100.1. Yes, this one M 100.2, this one M 100.3. Okay, and then we need to see the value of counter, right? So this one example MD20, MD30, MD40, and MD50. Okay, so that's all for create the program block. Yes, and then let save. Yes, and then let's go to the block and then download all, right? So go here, select all, and then right click, download, and then click all. Yes, and start the CPU. Yes. Okay, and let's check the OB1, and then online. Yes, and before start rotate the encoder, let enable this switch gate first. So I will go to data monitor. Yes, M100.0, right? M100.1, M100.2, M100.3. Okay, and I will let this one to true. Yes, select and add to true, and then we can start rotation. Yes, the encoder, and let's see the signal, right? So MD20, MD30, MD40, MD50. Okay, and we will monitor the data which decimal. Yes, Okay, so let's go to rotate the encoder. Okay, right now I will rotate the encoder. You see the input is working, yes, see, and the value is changed also, okay. Yes, you see the value is changed because I already connected the cable to all channel. Yes. So thank you very much for watching my video. And if everyone have any question, please drop comment under my video. I will reply soon. I hope this video is useful for everyone. And if I have mistake, I'm also sorry. Yes. And I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new video that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to read data from encoder by using PLC S7-300, CPU 314C 2PN/DP, part number second. Okay. In part number 1, yes, we already learned about how to read data from encoder by using PLC S7-300 also, but we just read and see the data in the SIMATIC Manager. Okay, but today I will create the new project for WinCC Flexible for create the value and so at the HMI also. Okay, it means that when I enable the switch gate, yes, example switch gate channel number 0, and I adjust the encoder increase or decrease, it will show the value on the HMI. Okay, and channel number 1, number 2, and number 3 also the same. Yes. Okay, so let's go to our software to create the new project of WinCC Flexible. Yes, and simulation. Okay, so first I will use the project SIMATIC Manager that we already learned in the previous video. Okay, let me open first. Okay, here is the existing project that we already learned in the previous video. Yes, about 4 channels of counter. Yes, so I will go to WinCC Flexible to create the new project and see the data from encoder on the HMI. Okay, so let's open WinCC Flexible 2008. Okay, I will create the empty project yes, and I will choose the multi-panel, yes. Okay, right now I will use the touch panel 170B6 in color, yes, to match with my panel. And first go to create the connection, yes. Example HMI, encoder HMI. Okay, and we will connect to the S7-300, right? And then comment. On HMI, okay, and I will use the Ethernet, right? If we would like to simulate, we can use the Ethernet, yes, or if we would like to download this project to the HMI, yeah, we can select this one and then use the standard or DP, okay. So right now I will use the Ethernet first because I would like to simulation. So 192.168.0.23 sorry .0.253, and the address of PLC is 192.168.0.1, okay, or we can ping first computer IP address, IP config, yeah, this is my IP, my computer IP, and we can ping to PLC 192.168.0.1, yes, so we can ping. You see here is the IP address of PLC, and here is the IP address of my computer, okay. So we need to create the text. Okay, to create the text, please click text and then go to see here. First is the enable, right? Switch gate. There are 4, yes. And start from address 100.0 until 100.3, okay. So we can write enable channel 0 switch gate, yes, it is the boolean, right? And start from M 100.0, switch gate enable for channel 0, okay. It is the channel 1, right? And we can copy, yes. So switch gate number 2 100.2, right? And switch gate number 3. Okay, 100.3 and channel number 3. Okay, and then we should have the value from other encoder, right? So start from MD 20. So channel number 0 value, and it is double word, yes, and start from MD 20 value of encoder channel 0, and then we can copy and paste and paste and paste. Okay, so here is the channel number 1, right? I will delete 1. Channel number 2, channel number 3, and 30, right? Yes, here is MD 30, 40 and 50, right? So channel number 1 and this one 40, channel number 2, and the last one for channel number 3. Okay, and this one is MD 50. Yes, so save our project, and I will save to keep on desktop. Create a new folder, data encoder. Okay, and the next we will create the screen, right, for enable the switch gate and read show the value on the HMI, right? So go to here, and then I will comment. So go to text, read data from encoder, go to font, yes, maybe 12, and center and middle. Using PLC S7-300 CPU 314C. So I can write CPU 314C 2pn/dp. Yes. And actually for this one we need to close this one, yeah, and check this one, because we need to adjust the text, right? Okay, so I need to have the 4 button, right, for enable the switch gate. Yes, so I need to create the button. Yes, channel 0 switch gate, and I will copy, or we can create the event. Yes, go to click and then go to invert bit, right? So invert bit channel 0 switch gate, right? And then if the text is enabled, we should show the green color also, right? So channel, yes, and tick bit, and then when it won, it will show the green color, right? And then I will copy for set. Okay, arrange, yes. Maybe I need to arrange a little bit more. Yes, like this, like this, and like this. Okay, and I need to change the text, right? For this one should be 1, and go to event, should be 1 also, right? And the text also channel number 1, this one channel number 2, right? So in one event should be changed to 2 also. Animation, okay, change to 2 also. And the last one for channel number 3, right? So 3, go to event and then change to 3 also. Yes. Okay. Okay, 2, 1, 0. Okay, correct. So we need to show the value, yeah, for each channel also, right? From channel number 0 to channel number 3. Okay, so I need to create the IO file. Yes, like this. And I will choose the output, right? And maybe okay, like this. And then go to property, and then go to center and middle, and then choose the font, right? Maybe I will use 16. Yes, and then change the color to be black, and then text color should be green. Okay, and I will create the text. Yeah. Okay, channel number 0 value, right? Okay, and then I will copy to faucet. Okay, like this. Okay, so we will adjust to be arranged with the switch, right? Okay, like this. And we just change the text. Yeah, channel number 1, channel number 2, channel number 3, right? Okay, and then save the project. Okay, and actually we can simulation. Yeah, like this. Okay, wait a little bit for simulation. Yes. And here I can switch. Example, I will switch the channel number 0 for switch gate, right? Okay, switch, you see, M0, sorry, 100.0 is turned on. And if I adjust the encoder, okay, I adjust the encoder, you see the value is vary, yes. And I will switch the switch gate number, channel number 1, yes. And adjust the encoder, yes. Channel number 2 also, yes. Channel number 3 also, okay. Oh, I will change this one, channel number 3. Wrong, okay. And then simulate again, yes. Okay. So let's test again. So if I adjust the encoder, you see, increase the encoder, you see the value is changed, yes. Decrease, yeah. Also the value is decreased, yeah. So if we would like to transfer this project of HMI to touch panel, we can also do it, but we must change this connection, yeah, to here, okay, and then change to the DP, yes, and then save the project and download to the HMI, yes. Okay. Wait a moment for downloading the project to the HMI. Yes, done. Okay. So right now we already download the project of WinCC to the HMI, and I will show the touchscreen. Yes. So if I adjust the encoder, yes, you see the point of PLC is turned on, and the type panel is vary also. Okay. So this is a instruction how to create the HMI, yes, for see the data of encoder by using WinCC Flexible version 2008 page 5. Okay, and I hope everyone will understand about my video, and if have any questions, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new videos that I will create step by step. And I'm so sorry if I have a mistake for in these videos. And finally, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC S7-300 CPU 314C 2PN/DP, yes, about the analog input. Here is the PLC module that built-in analog input and analog output in this slot, and also has more for digital input and output also. Okay, so I will connect it by using SIMATIC Manager version 5.6, and this is the IP address of my computer that I already manual to IP192.168.0.253, yes, and here is the default IP address of PLC 192.168.0.1, yes, and I will connect by using the RJ45 cable, yes, connect from the computer to the PN, yes, PN of the PLC CPU, yes. And I would like to explain the analog, yes. Actually, the analog input and output is already built in, yes, in this module that include 5 channels of analog input and 2 channels of analog output. Okay, that we can select input and output from here, and here is the address tab, yes. And when we would like to use the input type, example volt start from 0 to 10 volt or milliamp, yes, we can select here. I will test and explain when we use the software, yes. So here is the drawing detail of this channel, yes. There are 5 channels, yes, here. Start from AI channel 0 to AI channel 4, okay. And the last one of AI is the PT100, yes, that we can select 2Y or 3Y of the PT100, yes. I will test for detail, yes. So for AI channel number 0, yes, it will start the address from the configuration, yes. Here is the default configuration. Start from AIW, yes, AIW 800, yeah, until AIW 809, yes. And for analog output, start from AQW, yes, 800 also, and earn AQW 803, yes, 803, yes. So It is the detail, yes, of the analog signal that we can test for the CPU 314C 2PN/DP. Okay, it include with the CPU. Yes, we no need to add the some cards. Yeah. So let's go to our software to configuration and test with the selection. Yes. Okay, so let's go. So I will choose the SIMATIC Manager, yeah, version 5.6 for configuration and test with this unlock module. Yes. So first go to a new project. Yeah, I will create a new folder. Yes, create a new folder. Example test AI of PLC S7-300. Yes. And let's go to new and then choose the browse to find the folder, yes, that we already created. Example AI, yes, AI testing, and click OK. And then let insert new object for S7-300 station. Yes, double click hardware configuration, and then let's go to SIMATIC 300 and go to the rack 300 and drag and drop. Yes, and first let's add power supply. Yes, so PS example 10 amp. Yes, like this. And let's go to CPU 314, right? C 2PN/DP, right? So go to here and click here. Yes, version 3.3. It is the last version. It means that firmware version. Yes. So drag and drop. And here is the default IP. Yes. If we would like to set, we can set later, configure later. So in this section, I will click OK first. And let's see, here is the default address of analog input, digital input, output. Yes, counter. Yeah, it means that high speed counter, and this position control. So in this address we can change also. Yes, but in this section I will use the default address first. Okay, so let's go to configuration, the analog input. Yes, so here is the input. Yes, we can choose both type of input signal. We can use current or we can use voltage. Yeah, if we select voltage, it has two options. Yeah, we can use plus minus 10 volt, or we can use 0 to 10 volt. Yes, and other channel we can use current from 0 to 20 milliamp, or minus plus 20 milliamp, or 4 to 20 milliamp. Yes, actually I use 4 to 20 milliamp. Yes, so I will select two like this, all channel. Yes, And this signal we can select RTD type, yes, resistance. Example, this resistance or this resistance, yeah, PT100 standard, we can select also, okay. So it is the input type that we can select. If everyone would like to use voltage, yeah, example the analog input that we use voltage, we can select volt, yes, or current, we can select current, okay. So let's click OK and then save the project, and we can download to the PLC, yes. But before download, please check the communication between our computer with the PLC, okay. So let's go to network for computer and put the manual, yes, manual IP address. For my computer is already set thing, yes. Actually it show like this, yeah. So we can set it, yeah, go here and property and go to IP4, yes, here property, and then we can set 192.168.0.253 example, and we can ping, yeah, CMD ping 192.168.0.1, right? Here is the PLC address, so we can ping, yeah. And let's go here and go to the network connection and let diagnostic, yeah, and test, yes. It's already, it means that we can connect it to the PLC, yes, between our computer to the PLC, right? So click OK and then OK again, yes. And then let's go to our hardware configuration and click download, yes. Select all and click OK. Wait a moment, yes, for this communication. It take time a little bit, yes. Okay, right now it found one CPU, yes, that have address 192.168.0.1, yes. So click view. Yes, and then click here and click download, yes. So when we click this one, it will confirm stop the CPU, yes. You see right now the CPU is still running. Yes, the CPU is still running now. If I freeze OK, yes, it will stop the CPU, yes, and start again, yes. The CPU will running, okay. So let's save our project and then let's go to create the block for see the signal of analog, right? So I will open the hardware, yes, and minimize, and let's go to OP1. Yes, I will choose the ladder. So here we can write move, yes. So the address is start from 800, right? So I will move PIW 800, yes. Go to MW 0, yes. Let's click F1 to see, yes. We can write DB, yes, DBW, okay. I will use MW first. So let's download the block and then online, yes. And then select 2 decimal, yes. Right now it has data, right? So I will select to the milliamp, yes. Yes. Right now 4 milliamp I will show, yes. 4 milliamp the data is show 0. Yes. The data is show 0. So if I adjust the milliamp, yes. I will adjust the milliamp to 8, yes. You see the data is changed also. 12, yes. 16, yes. 20, yes. Is the maximum. And I can decrease, yes. 16, 12, 8, 4 milliamp. It will show 0, right? So if we would like to use other channel, we can write like this. Yes. So move again. So PI W 802, right? And this one MW 4 example, yes. And we can download, sorry, this one like this. Should be like this. I will add one more network, yes, and cut this one to here. Yes, and we can comment something, example analog input channel 0. and this is a analog input channel 1. Yes, and we can download again. Okay, so right now I already disconnect from this channel, so wait a moment, I will reconnect the cable to this channel. Yes, okay, so right now I already connected the cable to channel number 1. Yes, and let's see the result. You see the terminal that I already connected to here. Yes, and right now 8 milliamp. So if I adjust the current to 12, you see the raw data is changed also. Yes, and I can adjust. Yes, okay, so there are 5 channels, but the last channel I will show how to use it. Yes, okay, right now I will test with the last channel. Yes, of analog input. Yes, the channel for PT100. Yes, so we can input by ohm. Yes, example 100 ohm, it will show 0 degrees Celsius. Yes, so let's go to write the move value. Yes, so I will insert one more network. Yes, and command analog input channel number 4, right? The last one, PT100. Yes, so here is the 4 to 20 milliamp, and this one also 4 to 20 milliamp, right? So I can move. So start from PIW 800, right? So 802, 803, 806, 808, right? So PIW 808. Okay. And example MW20. Yes. So save the project and then download. Yes. Yes. Okay. So right now I provide 30 degrees. Yes. So if I adjust to 0, yeah, this is a 0 degrees Celsius. Yes. So if I adjust to 30, yes, 50 degrees Celsius, and this is 100. Yes, so it different around 2 degrees Celsius. Yeah, so if we would like to use this one to the HMI, we can yes, we can divide by 10. Yes, example take out this one and divide by 10, it will the same as the temperature of the PT ROI. Okay, so this is the instruction how to configuration the hardware of the CPU S7-300 CPU 314C 2PN/DP by using the Ethernet cable. Okay, and we also test with the analog input. Yes, and in the next video I will show and share about how to test the analog output. Yes, for this one. Yes, analog output. Yes, so thank you very much for watching my video. If everyone have any question, please drop comment under my videos. I will reply soon. And I would like to request all of you to like, share, and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today we will continue our lesson about how to create function that we call FCs. Yes. And this video I will show and share about how to create the analog input scaling. Normally we use 0 to 20 milliamp or 4 to 20 milliamp with raw data 32,767. Okay, and I will use WinCC Flexible software and SIMATIC Manager to create the function. Yes, and also create the screen. Yeah, for level hopper of powder. Example 0 to 150 tons. Yes, and we will got 4 to 20 milliamp, and this is the raw data that we will got from the load cell or from the level radar. Okay, so let's go to our software to create the program. So first I will use SIMATIC Manager to create the FC. Yes, and I will use the existing project that we already learned in the previous video. Yes, and I will use simulation. Yes. Okay, to create the FC, right click here and then choose the insert new object and then choose the function. Example FC2, and then this is a symbol. Example analog scaling, analog input scaling, and I will use the ladder. If everyone would like to use function block or structure text, we can choose. Okay, for me I use a ladder, and then go to double click on FC2. Yes, and here we need to put the parameter that we want. Yes, actually we use the formula for calculation for this scaling. So I will use the formula Q equal convert from integer to real, right? Because the input of analog is integer, so integer to real, then minus, right? Integer to real, it means that input, right? Convert input from integer to real. Yes, I will show the slide here. Here is the input, here is the high scale, and here is the low scale, and here is the output. So the input is the integer and the output is real. Example 79 tons, yes, it is the real. So we need convert from integer to real for input, right? So input convert input from integer to real, and then multiply by, yes, high scale, yes, high scale minus low scale, and divide all of these, divide by maximum of analog input value, here 32767, 32767, okay, 0.0, and then plus by low scale. Okay, this is the formula of this scaling. So we need to create the output, right? Output, input, high scale and low scale parameter. Okay, so for input I have 3. The first one is in, the second one is high scale, H scale, yeah, it means that high scale, low scale, yes, and for input is integer, for high scale is real, yes, low scale is real also, and the command we can write draw data from analog input. Here is the high scale, this one for low scale, yes, and for output I have only one, so Q, and it is the real, yes, data type. This is the output, yes. So first I need convert from input to the from integer to real, right? So I can use this one, integer to real, integer to real, right? Or we can convert from integer to double integer first, yeah. So integer to double integer, yes, this one, and then integer, double integer to real, right? This one. So I will choose in, and I need to create the temp for output integer to double integer, right? So let's go to temp and then choose here. Example output I underscore di, yes, and it is the di, right? Di in. So output I to DI, and then copy this one, Control C to here, and this is a real, right? So output, because this is the name that we want to use, we can use another name. Yes, example, this one output DI to real, and it is the real, right? So here I can use out DI to real. Yes, and I need to insert one more network. Yes, this one we can command convert from integer to real. Okay, and this one we need to multiply, right? Multiply the input with the high scale and low scale, right? So I need to use the sub real. Yes, this one. So sub between high scale and low scale, and I need to use the temp. Yes, output high scale minus low scale. Okay, and the data type is real also. So output high scale minus low scale, and then go to our formula. Yes, I will multiply all this to this one, right? So here subtract high scale between high scale and low scale. Yes, because we need to write some command for easy to read, for another easy to read. Yes, read the program. Okay, so here I need to create one more network for multiply, yeah, between this one and this one, right? So mul, okay, mul real, and then I can copy from this one to paste, Control V, and then enter, and copy this one to this one also. Yes, and I need to insert one more temp. Yes, output between mul real, yeah, and data type is real also. So out multiply real. Yes, and then I need to divide. Yes, all of this. Yes, so I need to create one more network for divide. Yes, and we need to write command mul input with high scale minus low scale. Okay, and this one minus, sorry, divide with max, right? Max scale or macro. Yes, macro data of analog input. Okay, so we can use divide by real, and I can copy this one, enter, and multiply by 32767. Yes, dot 0 also, right? Because it is the real, so dot 0. And I need to create one more for temp. Yes, so output divide real. Okay, and it is the real data type. So out divide real, yes. Okay. Okay. So we need to class, yes, with the low scale, right? So I use add, so I need to add one more network, and then this one add with low scale, yes. So I can use this one, so add real, and add this one with low scale, right? So low scale, and then this one is Q, right? Because it is the output, yes. So that's all for create the formula by follow this one, yes, to FC, our FC2, yes. So save the program, and if we would like to use this FC, let's go to OB1, double click OB1 and insert the network because it is the existing, yes. Example level of copper powder, rank 0 to 150 tons, yes. Okay, so I will drag and drop the FC, yes, FC2 from this one to this network to use, yes. So drag and drop. Okay, and this one is output for analog, right? So let's go to see the hardware, yes. Go to hardware and let's check the address of analog input, right? So here analog input start from PIW 800. So this one I can use PIW 800 to match with our hardware configuration, yes. And high scale, so high scale 0 to 150.0 ton, right? And this is 0.0, and here is the output that we would like to show on the HMI, right? So I can use MD example 1600, yes, like this. So let's save, and then let's download all this to the simulation, yes. Select all and then download to simulation, and then go to OB1 again, and then go to online, yes. The CPU is off. We will run the CPU again, yes. Okay, so right now it shows 0, yes. So if I adjust, so PIW 800, yes, and I will choose the slide for integer, yes. So if I adjust here, let's see, adjust to maximum, it will show 150 tons, okay, followed by this formula. If I adjust to this, yes, it will decrease step by step, follow our formula. So we need to use this one with the HMI, right? So let's go to WinCC Flexible to create the HMI, yes. Okay, minimize, go to WinCC Flexible. Right now I use 2008 ZB page 5 and go to existing project that we already learned in the previous video, and I need to create one more screen. Yes, so go here and then add screen. Example, I will rename to hopper 1. Yes, and then I will use the hopper, right? Let's go to library, go to the graphics, go to the symbol, yes, here, this one, and then go to the tank or hopper, yes. Okay, we can use hopper or tank that we want. Example, I will use this one. Yes, so drag and drop to our screen. Yes, and then resize to be the screen. Okay. So I need to create the text, right, for this analog. Let's go to text and then go here, double click. Example, hopper 1 level. Yes, and it is the real, right? And start from MD 1600. Yes, so start from MD 1600. So description level of hopper number 1. Yes, then go to our screen, and we can use the library. Yes, go to object, and I will use the bar. Yes, use the bar for show the level, yeah, of hopper. Yes, example I will show like this. So the rank is from 0 to 150. Yeah, you can change and go to the property and then use the color of face ground. Yes, example I use this color or this color to show the level when up and down. Yes, or this color. Yes, we can use another color that we want. Example, I will use this color. Yes, and I will adjust to be good looking. Yes, like this. And let's go to here, go to the general, and then this is a process, so I can use the text that here is the hopper 1 level. Yes, so I can use this one also for show the value. Yeah, the same as this one. So example, start from 999.99 or .9. Yes, like this. And I will adjust the font a little bit. So this one should be output, and go to property and adjust the font to be like this. Center and then the middle. Yes, and go to general property. I will change this one to be like this. Yes, text color I will use green. Yes, and for the unit I will use this one for example. change the color of text. Yes. Center, middle, and for property I will change to yellow. Yes. Okay, like this. So we can save our project and then simulation. Yes, this one I will use the text. Yeah, hopper, this one also. Yes, so save again and then simulation. Yes. Okay, so I need to call the screen this one, right? Because we already test it for another screen that we already learned in the previous video. So I will go to screen number 1 to call this screen. Yes. So let's go to screen number 1 and I will add one more button by copy from here. Yes. Example this one. So I need to put this button. Yes. Or I need to adjust. Okay, no need to adjust. So I will change this one to hopper. It means that call the hopper screen. Yes. I will adjust the font to be 12. Yes. And go to event. And then go to click and then call this name, right? So hopper 1. Yeah, it is the screen name. So we can save and then simulation again. Yes. So I will call the screen, yeah, for this hopper. Yes. And I will use the simulation for adjust the analog input. Yes, because right now I'm not yet connect to the PLC. Yeah, connect to the real PLC. So if I adjust this one to be 0, yeah, it will show 0. Yes. If I adjust this one to be like this, it will show by calculation. Yes. This one. Yeah. If maximum, it will show 150 tons. Yes. So this is a instruction how to create the analog input scaling by using SIMATIC Manager and show the HMI by using WinCC Flexible 2008 CV page 5. Okay. So thank you very much for watching my video. And if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to copy the FC of analog input scaling to show the value of the developer on the HMI. Okay. In the previous video, we already learned about how to create the FC. It means that function for only one hopper of powder, and we already simulation for show the level of hopper on the HMI. So today I will show how to copy the FC, yes, from the library that we already created, or we can just copy and paste and then revise the address and we can use another hoppers. Okay, so let's go to our software to create or copy both SIMATIC Manager or WinCC Flexible. Okay, so let's go. So first open SIMATIC Manager, and I will use the existing project that we already learned in the previous video. So first open simulation, yes, and then go to run, yes, the CPU. For copy this FC, let's go to EP1, yes, and here is the previous video of hopper number 1. So I will insert one more network for hopper number 2. So I can copy this one and then paste, and example hopper number 2, the rank from 0 to example 50 tons. Yes. So we have two ways for a copy. The first one, we can right click, copy and paste, and the second one, we can go to FC and then go here, drag and drop. Yes, we can do like this. So this one I will start from PIW 802. Yes, because it is the integer also, to compare with our hardware configuration. Let's see here. Yes, 800, 802, 803, 804, 805, sorry, 806 until 9. Okay, so rank 0 to 50 tons example, so 50.0, 0.0, and here is the output real. So I can start from MD 160.04. Yes. Okay. And for hopper number 2, I can insert one more, sorry, number 3, one more network and then copy from here. Yes. Hopper number 3, example 0 to 80 tons. Yes, and I can copy like this. So right click, copy, and right click and paste, and only change this one to 4, this one to 80.0, and here 4, it means that H. Yes, and for hopper number 4, we can right click and then insert network and then go to copy and paste. Yes, and just change this one to 6. Yes, and this one for command, so we can level hopper number 4. Yes, this one level hopper number 3. Yes, 1, 2, 3, 4. Okay, correct. And example 0 to 100 times. Yes, so I will change this one to 100.0. Yes, and this one should be plug 4, right? So plug 4, 1, 2, right? So 16, 1, 2. Yes. Okay, 4, H, 0, 4, yeah, 8, and 12. Okay, correct. So save our project and then download to simulation and then run. Yes, and then go to run the CPU. Yes. What's wrong? I will clear and then download again. Maybe have something wrong. MD0 yes, 6 4 H. Okay, let me download all this block to the CPU again. Yes. Let me clear and then run again. And then download all this block to the CPU again. Yes. Okay, good. So we can online and then run. Yes. Okay. So if we would like to simulation like this, example this one PIW 802, right? So if I use slide, yes, integer. So if I adjust, let's see here. Yes, the value is vary. Yes. Okay, one more for PIW 804 and go to slide integer also. Yes, let's see here. The value is vary also. And for the last one, PIW 806. Yes. Then I will adjust. Yeah. Let's see the value is vary also. Okay. So we need to show this level to the hopper on HMI, right? So let's go to our software WinCC Flexible to create the screen for show the hopper. Yes. So let's open WinCC Flexible 2008, page 5, then open the existing project that we already learned in the previous video. Okay, I will create hopper 1 again. Yes. So at the screen, okay, for hopper 1. Yes. We can also use another tank or hopper that we want. Yes. Example, I use this hopper. Yes, like this. Yes. And copy for hopper. Yes. Maybe smaller than this. Yes. Because I would like to use only one screen for this hopper. So we can adjust a little bit. Yes. Example like this. Yes. Okay. Like this. So hopper 1, hopper 2, hopper 3 and hopper 4. Yes. So I will use the object, yeah, for bar. Yes. And we can use like this. Again. Okay. Like this. For hopper number 1. Yes. And we can copy. Yes. Shift and control and then drag and drop the mouse for copy. Yes. Otherwise it not be the same. So for hopper number 1, let's see the rank. Yes. Hopper number 1, 0 to 150 tons, right? So let's change the scale to 150 tons and change color a little bit. Example, the color of hopper to be red or this one. Yes, this one rank from 0 to let me check, 50 ton, right? So 0 to 50 ton, let's go to general, change to 50. Yes, and change the color of the field. Example, this color. And one more for hopper number 3, 0 to 800, sorry, 0 to 80 tons. So 0 to 80 ton. Yes. And example, change to this color. Yes. And the last one, 0 to 100 tons. Yes. So that's correct. No need to change. I just change this one to this color. Yes. So hopper 1, hopper 2, hopper 3 and hopper 4, we already change the color or insert the bar for show. So I need to choose the value also. Yes, show the value. Okay. So go to the text. I will adjust a little bit to be 9 sample for font. And then go to general. And this one should be like this. And it is the output. And we need to change the property. Example, I change to the green for text, and for background I change to red. Yes. And one more for the unit, right? So example, tons. So I can use this one. Change color a little bit to be yellow. Yes. Or blue. Yes. We can change or design the style that we want. Yes. So here I can copy, drag and drop for copy, one more for copy, one more for copy. Okay, like this. So this one should be 100, right? So rank 0 to 100. This one should be like this. Yes, because the full scale only 50, and this one should be like this also. Yes. Then we can save and then insert the text to this one. So before insert the text, let's go to text. Yes. This this one I will rename to be a hopper screen, yes, and then go to the text. So we need to create the hopper one, right? So hopper one, it is the real data type and start from MD 1600, right? So 1600 MD 1600, yes, for hopper 1, level of hopper 1. So I can copy to another hopper, yes, and paste. Hopper 2, yes, 4, right? This one 2, yes. One more, paste. Hopper number 3, right? So 8, right? And then this one 3, and the last one copy and paste and change the name to be hopper number 4, and this one should be 12, this one should be 4, right? Okay, good. So let's go to here and then choose the text one by one for the screen. So this one should be hopper, yes, number 1. This one should be hopper number 1 also for process. This one should be hopper number 2. And this one should be hopper number 2 also, yes. This one should be hopper number 3. Yes. This one hopper number 3 also. The last one hopper number 4. Yes, so hopper number 4. This one should be hopper number 4 also. Okay. So that's also save our program and then use the simulation. But before simulation, I will call the screen name hopper. Yes. Yes. I will call the screen name hopper. Yes. So let's go to click event. Yes. So we can write hopper. Okay. And then we can save and then simulation again. Yes. Then call the screen hopper. Yes. Okay. So right now we can simulation. Yes. Let's go to here and then go to simulation. So I can adjust this one. Yes. Let's see. It will adjust also. Yes. To be maximal. Yes. This one also for hopper number 2. Yeah. You can adjust. Hopper number 3 we also can adjust. Yes. Okay. So this is an instruction how to copy the FC or function that we already created. Example, analog scaling. So we can copy and paste to use for another scaling that we want. So I hope this video is very helpful for you. Yes. And if I have another mistake, I would like to say sorry. Yes. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos. that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about PLC S7-300 CPU 314C 2PN/DP about the analog output. In the previous video, we already learned about analog input, yes, and we already tested and wiring the diagram from PLC to test with the standard source milliamp, yes, and already setting, yes. So today we will continue to analog output. I will explain for easy to understand. First, let's go to see the CPU, yes. For analog output card, it also built in the CPU, the same as analog input also. And here is the drawing, wiring diagram, yes. There are two channels for analog output with this CPU, okay. And this is a drawing diagram. You see the channel number 0, AQ, yeah, or AO, you see. Actually, the current and voltage we can select here, yes, select here. If we would like to use the volt, we can use the volt. If we would like to use the current, we can also use the current, okay. Actually, these two terminals, A it means that plus, and V it means that minus. When we connect to some electrical devices, example drive, VFD, or some electrical devices that use milliamp or volt, okay. And I will use SIMATIC Manager software for connect to the PLC for communication. Download, yes, download the program, and I will set IP of my PC 192.168.0.253, and this is the default IP address of the PLC 192.168.0.1, and connected via RJ45, or we can call LAN cable, okay. And here is the setting we can set. I will show in the software, yes. So let's go to test with software. In this section, I will connect with the HMI for this signal, and I will use the WinCC Flexible for connect also, okay. So let's go to our software. So here is the software, SIMATIC Manager and WinCC Flexible. In here I use the version 5.6, and for WinCC I use WinCC Flexible 2008 page 5, okay. So first let's go to SIMATIC Manager, and let's check the IP address. We can use like this, IP config, yes. You see here is the IP address of my computer, because I already manual, yes, here. Actually it doesn't show like this, so we need to manual. And create a new folder, yes, for new project. Example S7-300 AO or AQ. Okay, so create new project S7-300 AO, yes, and browse to a folder that we already created, yes, the folder, and click OK. So first we need to create the station, yes, SIMATIC Station 300, and here we can rename example AO, yes, and double click, yes, hardware configuration. Let's go to tab S7-300, go to rack and rail, yes, drag and drop, yes, and then we will create the power supply like this. Example, we can do like this, but the actual real work we can compare with the nameplate of the power supply, yes, before insert to the rack, right? So the next we'll create the CPU. Right now I will use this CPU 314C2PN /DP, yes, and here's the last version 3.3, yes, firmware version. And you see here is the default of IP address for this module. So we can click OK, yes. For this card, yes, you see AI5/AQ or AO2. It means that in this module of CPU, it already built-in 5 channels of analog input and 2 channels of analog output. Okay, so here is the address. It will start from PQW, yes, we can say PQW 800 until PQW 803. Okay, so here double click here. Here is the address. Actually we can put the manual mode, but in this section I will use the auto address first, that it already mapped on the SIMATIC Manager. Okay, so here is the input we already learned in the previous video, yes, yes, previous video we already set this one, but today we will focus this tab. Okay, for this tab we can select also if electrical devices that use V, it means that volt 0 to 10 volt or plus minus 10 volt, you can select V. Okay, for in this section I will choose I because I have the standard source or meter or my electrical devices used for to 20 milliamp, so I will use current, yes. Okay, so after finish the setting, we can click OK and then save and compile the project, yes. And let's go to here, go to option to set PC interface. It means that check the communication between our PC with the PLC, okay or not. Okay, so let's go to this network, yes, active diagnostic, and then click test, yes, It's so like this, it means that we can communication between our PC with the PLC. Okay, so click OK, and actually we can use the command prompt and ping 192.168.0.1, right? Ping from our computer to the PLC. Okay, it's so like this, it means that we can connect. Yes, so let's go to here and then click download, select all, and then click OK, and take time a little bit for communication before we can download. Okay, so wait a moment. Actually we need to know the wiring is very important. Yes, here is very important. If we don't know the wiring diagram, we cannot connect with our electrical devices. Okay, so it is very important for diagram of this module. Okay, so here we it found one CPU 192.168.0.1, right? So we can click view, yeah, here, and click OK. Yes, and download. Yes, download. Okay, and let's go to check the program. Yes, we can write program sample for test. So double click on EP1, and I will choose the ladder. Actually we can use static function block. Yes, and ladder. So in this section I will use ladder. So here we can comment. Yes, test analog output of PLC S7-300 with LAN cable. Yes, okay, so here we can move. Yeah, we can use move. So move. Yes, we can use move to address, right? So PQW 800. Yes, like this, because the hardware configuration is start from PQW 800, right? So we can use 800. Yes, and I will use the move. Yes, example from Word. So this one I can use the VW0, or we can use VDW. So the input will be like this. Yes, you can freeze F1. Yes, for check the input. So we can move. Yes, W. Yes, example W 0, yes, to the channel number 0, and we can also copy and use MW example 100 to PQW 2, right? Channel number 1, yes. So save our project and download to the PLC, and then we can online, yes. Decimal, yes. So MW, actually we can test like this. MW 0, right? So here we can choose 0, yes. 0, the milliamp will show 4 milliamp, right? And if we set to the maximum, yes, I will change to decimal, maximum around 27684, right? Around this, yes. The milliamp will show around 20 milliamp something, yes. And for the channel number 2, sorry, channel number 1, we can also MW 100, yes. Decimal also. If I set 0, it will show 4 milliamp, yes. And if I set the maximum 27684, yes, it will show 20 milliamp, okay. So we can write the touch panel to set this point also, right? Example, convert from 0 to 100%, yeah, and the output will start from 4 to 20 milliamp, yes, like this. Okay, so let's go to our software WinCC Flexible to create the sample screen, yes. So open the WinCC Flexible and create the empty project, yes. I will use the panel, yes, touch panel, example this one, yes. So first let's go to connection, yeah, to set the connection. It's very important because we need to use the connection first, yeah, to configure the connection first before we can online and simulation with the CPU of PLC, okay. So example connect AQ, yes, and I will choose the SIMATIC S7-300 400, right? So many driver that we can connect, yeah. Example S7-200 or some protocol, Elentrale, GE, yes, Omron, yes, many brand that we can use. So right now I will use the SIMATIC S7-300 400, okay. And we can command connection for test with analog output, yes. Okay, and first we need to use the Ethernet, right? Because right now we connected with the RJ45 or LAN cable, yeah. And here is the IP address of computer. So 192.168.0.2, Okay, IP my computer 253, right? Okay, 253, yes. And here is the IP address of PLC, yes. So 192.168.0.1. Okay. It's very important if we not configure the IP address, we cannot simulation with the module. Okay. So let's click save and save to desktop also and go to our project. Yes. HMI of HMI AQ, yeah, like this. Okay, after create the connection, let's go to text. Yes. So I will use the set point. Yes. Set point CA0, right? Set point for channel 0. So the data type is word, right? So start from MW0, yes, for channel number 0. You see here, MW0 is channel number 0. And the second one for channel number 1, right? So start from MW100, yes. It is just example. If we know the concept, so we can do everything. Okay, so in this video it's just example for how to test. Yes. So after that we can go to screen, yes, and go to the text file. Yes, so we can write something. Example, test AQ with CPU 314C 2PN/DP. Okay, like this. And we can go to property, go to text, and we can center and middle, and we can adjust the font, yes, to be like this. Adjust to be small a little bit, yes. Okay, we can adjust. Okay, so if we would like to set point from touch screen to the PLC, we can use the IO file. Yes, so click and then drag and drop. Yes, so here we can use the format. Yes, middle and font maybe 18. Yes, and go to the general and format. This actually we can use example 999.9, right? Okay, like this. So here we can choose the text. Yes, go to text and then go to MW0 and click here, and we can scaling. So when the PLC is, yes, when the HMI is 0 to 100%, the PLC will show, yeah, will set the PLC will show the 27648 something, yeah, example like this. So we can save and we can write here, it is the input, right? .9. So it is the PQW800. Yes. Go to property, go to font. I will change this one to black, and this one to white, this one to green, and yes, I will choose white. Yes, like this. So can save and can simulation for test. Yes. Okay, so let's test for channel number 0. Yeah, example 10%. Yes, yes, 10%, and this is a 100%. Yeah. Okay, when I set 0%, yeah, let me show the milliamp. Yes, you see right now the milliamp is show 4, around 4 something, 399 milliamp. So if I adjust to example 50%, it will show 12 milliamp actually. Yes, but this one show around 11.9. Yes, if I set 35%, yes, you see around 16 milliamp. Yes, and 100% it will show 20 milliamp. Okay, right? So we can use like this for config with the HMI for test, right? Because actually it will set point from 0 to 100% or something. So we need to scale the text. Okay. For PQW82, yes, we can also do like this. Yes, go here and then just change this one to 1, right? This channel. And actually this one we can write percent, right? So percent, and we can change to the yellow or some other color. Okay, like this. Yes, we can save and we can simulate again. Yes. Yes. So if I set point to 0, this one to 0 also, you see here is 0. Please wait a moment, I will connect to the channel number 1. Yes, right now you see the channel number 1 is show 4 milliamp. Yes, because I set 0. If I adjust to 50%, yes, 50%, Yes, 100%. PQW 82, right? PQW 100. So we need to scale also. Yes. Input and then scale. Yes. Go here and then click here to scale. So PLC will 278648. Yes. And we can simulation again. Yes. You see here is 0. Yes. And the milliamp will show around 398. Yes. 3.98. If I set to 50%, yeah, you see the milliamp is adjust to 12 and 75. Yes, 16, 100%. Yes, around 20 milliamp, right? So this is a instruction how to test the analog output of PLC S7-300 CPU 314C2PN/DP via LAN cable and use the software SIMATIC S7 Manager and WinCC Flexible. So thank you very much for watching my video. If everyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. I hope this video will help everyone to test the analog output for PLC S7-300. Okay, so in this time I would like to say thank you very much and also sorry if I have mistake, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to add config the analog output model SM332 58F00 0AB0. Okay, here is the analog module, yeah, of PLC S7-300, and here is the detail of terminal, yes, for wiring from channel 0 to channel 7. Okay, totally of this module we have 8 channels for analog output, and I will use SIMATIC Manager software to config and download to the CPU 314C2PN/DP. Okay. This part is the on board of I/O, yes, and this is the external card. In the previous video, we already learned about how to add the analog input, this model, and we already tested with the actual PLC also. Okay. So before go to configuration, I would like to explain a little bit about the wiring connection of this terminal. Okay. So there are 30 terminals in this block, yes, in this module. For 1 to 30 terminal for channels, and from this to 38 for channel also. Okay. So first I would like to explain about how to wiring when we select to use voltage. So let's go. So if we would like to use the connection via voltage, we can use this terminal. Yes. Let's see here, channel 0, channel 1, channel 2, channel 3, channel 4, channel 5, channel 6 until channel 7. Okay. This is a 4-way connection with voltage. Okay. And I will draft this one, conclude this one also between voltage and M. Okay. So the second one I would like to show how to wire it with current. Yes, this one. It is the model name. Yes, and this is the wiring with current output. It starts from channel 0 until channel 7 also. Okay. So this is a wiring with current, and I would like to drop all this for show also. Yes, here is the conclusion for this 2 with volt or current. For voltage, we will use terminal number 4 and number 5. Number 4 is plus, number 5 is minus. And if we would like to use the current output, we can use number 3 and number 6. Number 3 is plus and number 6 is minus for channel 0. And for channel 1, we can use the same. Yes, number 7 is plus, number 10 is minus for current, number 8 is plus for volt, number 9 is minus for volt. Until channel number 7, yes, because totally number of channel is 8. And don't forget supply the voltage 24 volt to terminal number 1 and number 20. For number 1, we connect with the 24 voltage plus, and terminal number 20 we connect 0 volt. Okay. So this is a drawing of this model. Yes. So let's go to configuration. Yes. Okay. So first open SIMATIC Manager version 5.6. Right now I use it, and I will use the existing project that we already learned in the previous video. So let's go to hardware configuration, and then go to the SIMATIC 300 and go to SM, and then go to AO, right? Because we use AO. So let's go to find the model that we use. This one, yes. Let's see this one compare with the slide, yes. Okay. 33258F00, okay. 33258F00, okay. So drag and drop this one to the slot, to the rail, yes. And then make the configuration, yes, here. So to configuration with the wall or M for output, we can double click and then go to output, and this start address, earn address, we can use the default, but this one we can change. Example, channel number 0 until channel number 7, yes. So if we use example channel number 0, I use current, so I can select from 4 to 20 milliamp or 0 to 20 milliamp, okay. Right now I will use current for channel number 1, number 2, number 3 and number 0. And for channel number 7 until, sorry, number 4 until number 7, I will use volt, yes. And then I will use 0 to 10 volt, yes. 0 to 10 volt, 0 to 10 volt, and this one also volt, 0 to 10 volt also, okay. So channel number 0 until number 3 is current, yes. 0 until number 3 is current, and number 4 until channel number 7 is volt, okay. And I will test one by one to show for everyone about how to measure the current and volt by using the multimeter, okay. So that's all for configuration between analog output 8 channel of PLC S7-300, okay. So after we configuration, click OK and then save the project, yes. And I will download this project to the PLC. After that, I will test one by one of channel to show, okay. So let's go. Okay, before download to the PLC, please make sure we can ping from our PC to the PLC via 192.168.0.1, okay. So it reply like this. It means that we can connect or communication between our PC to the PLC. If we cannot ping like this example, I will take out the LAN cable, yes. It shows like this. Let's check the communication, yes. Make sure we put the manual mode for the LAN cable, yes. I will show here. We must put the manual IP address 192.168.0. Anything but not 1, okay, because IP1 is the IP of the PLC, okay. So right now I connect back to the PLC for LAN cable, so I can ping again, yes. It connected, okay. So let's go to download, yeah. Click this button and then click select all and click OK, and then wait a moment for connection, yes. It will found automatically between PC and CPU, so wait a moment. Actually we can use this channel or this analog to control another device, example damper or VSD or everything that use 0 to 10 volt or 4 to 20 milliamp or 0 to 20 milliamp. Okay, so I will click view for view the CPU status. Yes. Okay, right now it found one CPU. Yes, that the same as the IP address that we ping. Yes, so click OK and then click OK and then click yes to download. So right now we already download to the PLC. Yes, and now and then we can test. Yeah, to test the signal, please remember the address that start. Yeah, it will start from PQW 272, right? So let's go to PLC and then go to the monitor modify variables. Yes, and then write the IP or write the address. Yeah, so PQW 272. Yes, and change this one to decimal. And please remember, yes, please remember these values. Yes, it is the same as the analog input also. Yes, this one. So when we put 0, it means that 0 milliamp or 4 milliamp. And if we put this value, yes, we will got 20 milliamp. Okay, so 2764H. Okay, so we can modify the value 2764H and then click this button. Yes, we will got 20 milliamp. Yes, I will show on the multimeter. Okay, right now let's see here the channel number 0 is show 20 milliamp. I will decrease the value. Yeah, example 1300. Yes. Yeah, let's see around 11 milliamp. Yes. Okay. And if I set 0, it will show around 4 milliamp. Yes. Okay. Example 8000. Yes, 8000. Around 8 milliamp. Okay. In the next step, we will test with the voltage, right? So for channel number 4, yes, channel number 4, we will set from 0 to 10 volt, right? So channel number 4, I will use the, yes, PQW, where it will start from PQW 274, right? PQW 276, PQW 27H, yes, PQW 27280, right? And I will change this one to decimal also. Yes, and I will connect the multimeter to this channel. Yes, so please wait a moment. So this is channel 4. Yes, right now I already connected and select the meter to volt. So if I set 2764H and let's click here. Yes, let me show the volt. It will show 10 volt. follow our configuration. Yes, let's see here, 10 volt. So if I adjust degrees to 0, yes, it will show 4.7 volt. Okay, 8000, it will show 2.8 volt. Okay, so it will follow our configuration. If we select this one with current, it will output with current. So if we select this one to volt, it will output with volt. Okay, so it will follow by our configuration and connect to our device that use. Example, VSD use the volt, we can select volt. VSD or some electrical devices use current, we can select current. Okay, so thank you very much for watching my video, and if everyone have any question, please drop comment under my video. I will reply soon. And I would like to say sorry if I have a mistake in this video also. And I would like to request all of you to like, share and subscribe my channel also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about software SIMATIC Manager version 5.6, about how to add, configure, test the digital input module of PLC S7-300. And here is the push button that I already connected cable from the NO and NC contact to the terminal of digital input module. Yes, and here is the module of digital input, and here is the serial number. Yes, for digital input module, I already insert to the rack of the CPU with analog input and analog output that we already learned in the previous video. Okay, so today we will learn more about digital input module. Yes, so before go to make the configuration, I would like to explain a little bit about the drawing of this module. Yes, so let's go. So here is the drawing of a digital input module that I already draw. Yes, there are 20 terminals of this module from terminal number 1 to 20, and we must provide 24 voltage plus or positive to terminal number 1, and for terminal number 20 we must put 0 volt or 24 volt minus. Okay, so here is the example of push button that I already mentioned in the slide. Yes, and here is just example for push button number 1, I 0.0. Yes, and push button number 2, I 0.1, and it will earn from I 1.7, because totally we have 16 bits for this module. Okay, so it's just example to easy for understand about this module. Actually we can test after we do the configuration. Yes, so let's go to our software to make the configuration of this module, but should be remember of this module 321, sorry, I'm mistake, 1BA02. Okay, so let's go to our software. So first let's open SIMATIC Manager version 5.6 that I already use the same as previous video, and I will use the existing project that we already learned about how to add the analog input and analog output module. Okay, so let's go to hardware for add one more. Yes, so let's click hardware configuration, and then let's go to SIMATIC 300. Yeah, and then go to SM300 and go to digital input, right, this tab. Yeah, and let's find, yes, compare with the slide. Yes, let's find, yes, 321 1BH02. Okay, 321. Yes, so go to 321 and 1BH, right, BH02. Yes, this one. Let's see here, it is the module number. Yes, so let's drag and drop this module to the rack. Yes, and then let's check the address. Yes, it will start from I 8.0 until 9.7 because totally is 16 bits. Okay, so let's go to save and then download to the PLC, yeah, to the CPU about this new module. Yes, so let's wait a moment for connecting the cable. Yes, it will detect automatically between our PC and CPU. So make sure it should be can ping. So let's go to command prompt and then ping cmd, and then go to ping 192.168.0.1. Okay, let's see. Here is reply from the PLC, so we can ping. It means that we can communication between our PC and then with the PLC. Okay, so let's click view to view the PLC because right now it found one CPU. Yes, so here is the IP address that I already show here. So let's click OK, and if I press OK, it will stop the CPU. Yes, let me show. So if I press OK, yeah, let's see the status. It will stop the CPU and download program to the PLC and then run again. It will restart, yes, the CPU. Okay. For test the digital input for this module, let's go to test by go to the PLC and then go to the block. Yeah, go to the PLC and then go to monitor, modify variables. and it will start from 8.0 until 9.7, right here, 16-bit. So we can write I 8.0, I 8.1, that I already connected cable from push buttons to this module, and then I will zoom a little bit, zoom in, yes, for easy to see, yes, zoom in. So here I can freeze online, yes, to check. Okay, so if I push button, okay, let me show. If I push button, yes, to this button, let's see, I 8.0 is turned on, and the PLC is show true also. For this button also, I 8.1, yes, it show also. Okay, so we can test, and this wiring is correct, yes. So we can write sample program for test also, yes. So let's go to our block, and then go to OB1, example start stop, yes, stop, start, coil, and hold the signal, right, for coil, yes. So example this one I 8.0 for stop, I 8.1 for start. Actually we can modify the symbol, yeah, by edit this one, yes, and this one will turn on one output, yes. Let's check the internal CPU output, yeah, it will start from Q136.0, right. So example Q136.0 is turned on when we push button start. Okay, then it will hold the signal, and we can save the project and download program to the PLC, and then we can online for test. Okay, I will zoom in, yes. Okay, so let me show it will turn on, yeah, this one will turn on after I push the button. Okay, so let me show. Okay, right now I will push button start, right. Okay, let's see here, this turn on also for output, and for the PLC status in our software also show, yes. Okay, so when I push stop, it will stop. When I start again, it will start again, yes, stop, start, yes. And we also show the status in here also, yes. Example Q136.0, right. So right now it's true, yes, let's see true. So when I pull button stop, it will fall, yeah, it will stop, true again, yes. So this is just example or instruction about how to add the digital input module of PLC S7-300. How to download or how to test, see the signal, yes. I hope this video is useful for everyone, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my channel again, General Technology Knowledge. Today I would like to show and share about how to add, configure the analog input module of PLC S7-300, module SM3317KF02 0ABA0. Okay, and I will use the CPU 314C2PN/DP. Actually, in this CPU, it built-in 5 channels of analog input already, and also digital input and output also. Okay, but in this video, I just want to show how to add one more or another channel of analog input module to meet with the input, meet with the CPU. Actually, if we have only 5 channel, we not enough to use, so we can add more for analog input module. Okay, and I will use SIMATIC Manager version 5.6, and here is the module of analog input, and here is the configuration points that we must know the function. Okay, so let's see here. There are 4 functions of each module or of each channel. This is channel number 1 and 2, 0 and 1, 2 and 3, 4 and 5, 6 and 7. So totally it has 8 channels for this module. Okay. So I would like to explain step by step about how to select to be a correct function to use. Yes. There are 4 functions here. A means that we can use the PT ROI or millivolt or ohm, yes, that we want. It means that input millivolt or PT ROI or TC that we would like to use. So we can select A to be a channel number 0, 1 or 2, 3 or 4, 5 or 6, 7. Okay. So if we would like to use 2.5 volt or 5 volt or 1 to 5 volt or 10 volt, we can select to use B. Okay, we can rotate from B to here. Yes, so we can got this function. So if we would like to use 0 to 20 milliamp or 4 to 20 milliamp, we can select C to be here or here. Yes. For Y and 2Y, yes. I will explain in the next video about 4Y and 2Y for current. And I will use the drawing that I draw for explain to everyone also, because we have 20 terminals, yes, totally in this module. So let's go to drawing how to wiring this module. Yes, because before we do the configuration, we must know how to configure and how to wiring this module. Okay, So it is basically for know or programmer to know how to configure the module or how to wiring before testing. Okay. So let's go to drawing. So here is drawing of this module that I already test or draw. So there are 20 terminals in this module. For terminal number 1 and number 20, for number 1 we must supply 24 voltage. This is a plus and this is a minus. Otherwise this module is not work if we don't supply the 24 voltage to terminal 1 and terminal 20. Okay. And there are 8 channels, yes, that I already mentioned before. This is channel number 1. Let's see here. When we connect minus to terminal 2, it will not work. So we must connect or wiring plus to terminal 2 and minus to terminal number 3. And the same as here. For 10 and 11 terminal we not use. Yes. So each channel we can wiring the same my drawing that I already draw. For example, channel number 2 we can wiring plus to terminal number 4 and minus to terminal number 5. And for the same, if we would like to use the channel number 8, we can supply milliamp or volt to 18, yeah, terminal 18 for plus, terminal 19 to minus. Okay, because here is the basic. So let's go to manual operation. Yes. So here I just draft any function that we can use. So they already separate, yes, between the rank that we can use. So here is the under overflow, yes. Example minus 3.52 milliamp, yeah, or 1.185 milliamp, yes. That is the under shoot rank, yes. For rank that we use is 4 to 20 milliamp or 0 to 20 milliamp. And here is the raw data that we can use this rank to scale of analog input that we want to use. Okay. For 22.81 milliamp, it is overshoot rank, yes. It not acceptable, and this one also overflow rank, yeah. So the rank that we can use is the rated rank, 4 to 20 milliamp or 0 to 20 milliamp or 0 to 27,000, yes, that we can use. Okay. So it is just example or basically for understand before we do the configuration. Okay. So let's go to our software to make the configuration of this module. Yes. So first I will use the SIMATIC Manager version 5.6. Yes. Okay. And I will use the folder. Yeah, I will create a new folder. Add analog input. Yes. And I will use the new project. Yes. AI S7-300, and I will browse to use the folder that we already created in the desktop. Okay, so analog input, right? Yes, here, then click OK and go to right click and add SIMATIC 300 station. Yeah, I can rename example PLC S7-300. Yes, and double click and then go to hardware configuration. Yes, and then go to add the rack. Okay, you can add the rail. And go to the power supply. Yeah, actually we can add power supply. It is optional. Yeah, so I can drag and drop the one more power supply and go to the CPU. Yes, we need to use the CPU. So right now we will use the CPU 314C 2PN/DP version 3.3. Yes, drag and drop. And then here is the IP address and subnet mark. So click OK first. And we will add the one more for analog input, right? So let's go to the SM300 and let's go to AI. Yes, and don't forget this one. Yes, SM331 7KF02. Yes. Okay, let's scroll to find that one, the same as the nameplate. Yes, this one we already found here. Let's see, here is the module. Yes, number that we use. So let's drag and drop to here. Yes. So basically we can double click to see the address. It will start from 256, and here is the configuration that we must know also. So if this one example I select to A, it means that PT Roy, right? PT100, and other channel I will use select to C. It means that 4Y current, yeah, 4 to 20 milliamp or 3 to 20 milliamp. Sorry, 0 to 20 milliamp. Okay, so I will select channel A. Sorry, channel 6 and 7 for PT100. Otherwise, sorry, other channel I will use 4 to 20 milliamp and 4Y. Okay, so let's select and config. So here is channel number 0 and 1. So I can select 4Y, yes, and select 4 to 20 milliamp, channel 2, 3 also, yes, 4, 5 also, but channel here, channel 6 and 7, I will use resistance, yes, here. So I can use AR4L or ART, yes, resistance. So I will select AR, yes, like this. Or we can select ART, yes, standard PT100, yes. So we must select the configuration to match with the hardware. Otherwise it not work and have the fault also, module fault. Okay, after select, please click OK and then save the project. Yes. And for on board, there are 5 channels already for input. Yes. We can also configuration. Yes. Here example current. Yes. Current. Yes. For 220 milliamp. Yes. And this one example standard. Yes. Standard PT100. Yes. And then save again. And I will download this project to the PLC. Yes. Okay, so but before download, make sure we go to the computer and network. Yes, local area connection, and go to the put the manual. Yes, here to be to rank with the PLC, because the PLC CPU is 192.168.0.1, right? So we can put another IP, but not equal 1. Okay. And then we can check between our PC with the PLC by using the command prompt cmd and then ping 192.168.0.1. Yes. If it shows like this, it means that we can connect from our PC to the PLC. Okay. So we can go to here and then click download, select all, and then wait a moment for the PC will automatically detect with the PLC via IP address that we already set. Okay. So wait a moment for this step. Actually, we can wait around 1 or 2 minutes. Yes. Right now it detects one CPU. Yes. Let's click view. Yes. And then click OK. Yes. And it will download. Yes. Automatically download. Yes. And then start the CPU. Okay. So to test the analog input, let's go to the block or go to here. Yes. Yes. Monitor, modify variables. Yes. And it will start from the PIW 256, right, for channel number 1. Yes. So PIW 256 and change this one to decimal. Yes. And then we can online to check. Okay. So right now it shows 0. Yes. So if I adjust the milliamp, right now it's 4 milliamp. Yes. So I will adjust the milliamp to bigger than 4. Yes. Okay, I will adjust. Right now I adjust 8 milliamp, 12 milliamp, 16 milliamp, and 20 milliamp. It is the maximum. Yes, around 20,000 something for 20 milliamp, and here is 12 milliamp around 13,000 something. Yes. Okay. So if we would like to test channel number 2, we can also test, yes, PIW 2 Y 8, right? Yes, I change this one to a decimal also, and I will select, yes, wiring the connection to channel number 2. Right now I already connected to channel number 1. Yes, I will select to channel number 2. So please wait a moment. So channel number 2 should be terminal 4 and 5, right? 4 is plus and 5 is minus. Okay. So I will select and wiring. So right now I put channel number 2, yes. So if I adjust the milliamp to be 4, yes, it show 32, yes, or 0, yes. I adjust to 12 milliamp, 16 milliamp, and 20 milliamp, yes. The value is error a little bit, yes, because my standard source is also accuracy is error a little bit, yes. So this is a instruction how to add more analog input card to the CPU 314C 2PN/DP, yes. And about how to test a wiring or use the manual operation, yes. So thank you very much for watching my video, and if anyone have any question, please drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. And I'm also sorry if I have mistake in this video also, yes. And in this time I would like to say thank you very much again, and see you next videos. Bye bye.